Welcome to the Complete Guide to Node.js by Packt Publishing. I'm Joshua Johannan. I'm the author of Building Scalable Apps with Redis and Node.js and the Web Developer's Reference Guide. Both of these books are available from Packt Publishing, and I highly recommend them. Now, I've been a developer for over 10 years. I've used many different languages and frameworks over that time. These include PHP, Python, .NET using C#, and JavaScript on both the front end in browsers and the back end using Node.js. I also try to make blog posts regularly on my blog. So in this course, we will cover the foundation of what Node.js is. This will take the viewer from never having used Node.js to understanding how the basic modules work in Node.js. In addition to this, we will cover asynchronous programming, which is something that most developers have not used before, but is absolutely needed when mastering Node.js. First, we will look at installing and using Node.js and NPM. Then we will look at how the Node.js module system works. Then we will cover the paradigms in use in Node.js. After that, we will look at the three most useful modules in depth, which are events, streams, and HTTP. Finally, we will look at the most used web framework for Node.js, which is Express. So we're going to take someone who has never even seen Node.js before and make them very comfortable when writing code in Node.js. Now for this course, the only thing you need is a text editor. I'm personally going to use GitHub's Atom editor for this course, but you do not need to use this, and any text editor will work. Anything that can edit text is all you need for this course. So at this point, you are probably tired of hearing me talk about the course and want me to start the course. And I agree. So let's get started to learn how to use Node.js. Hello and welcome to Using Node.js and NPM. This is the first section of the course, the Complete Guide to Node.js. In this section, we will install Node.js, launch Node.js as a REPL, go over the fact that Node.js is just JavaScript, and then install a package with NPM. In this, the first video of the section, we will go over how to install Node.js. Then after it is installed, we will launch it with and without a file. So, first thing we need to do is go to the site, download Node.js, then install it and run it. So let's go ahead and get started. First, we will need to go to the Node.js site, which is nodejs.org. As we can see on the page, Node.js is built using the V8 JavaScript engine in Chrome. Now, Chrome is open source, which allows developers to utilize the V8 JavaScript engine like Node.js. So a few things to take note on this page is that Node.js is event-driven and non-blocking. Now, if that doesn't mean anything to you now, that is okay, because we will cover what this means in section 3 of this volume. The other thing here is that Node.js uses a package manager called NPM. So we will learn about NPM in this section, but not this video. So as you can see at the bottom, there are two options to choose from when downloading. The first is version 4, which is an LTS. Now LTS stands for long-term support. What this means is that for 24 months, this release will be supported. Now, what we're going to do is install version 6 today because it is a current version. And it will stay the current version until October 2016, in which it'll then become an LTS. And then it'll keep that status until April 2018. Now, in October 2016, version 7 will be released of Node.js. Now, version 7 will not become an LTS. And this is because only even versions become LTS and odd versions do not. Now, if this is a little hard to visualize, what's great is that Node.js gives us a great graph to visualize this. So let's take a look at that. So here's Node.js's visualization of what's currently current, what's an active LTS, and what has ended, what is at end of life. So this is Node.js graph of what is current and in an active LTS. So we can see version 4 here. We are about here in the graph, and that we're in an active LTS. Now this is after version 5, which did not get an active LTS. So version 5 is no longer current, which means version 6 is current. And then after we hit October 2016, version 6 will become an active LTS until April 2018. And in October 2016, version 7 will be released and be the current version. So hopefully this makes what we just talked about with LTSs and current a little bit easier to understand. So let's go back and actually install Node.js. So today the current version is 6.3.1. Now, when you watch this, this is most likely going to be a different version, but that is going to be okay as long as it's version 6. And honestly, version 7 should not make too many breaking changes, so version 7 should work as well. So I'm going to go ahead and click this and install it. It's going to download, and then I'm going to run the installer. Okay, here's the installer. Now I'm using Mac OS X, but if you're using Windows, it should be very similar in that you just hit continue or next, next, next. There's not too much that you can do here. I'm going to continue. I'm going to install. Alright, going to edit this out. Don't want to log in, pop in here. Okay, so now it is installing. This should just take a second. And Node is installed. So let's go ahead and close this and open a terminal and then use Node. So here's a terminal. We're going to go ahead and run Node and make sure that it is installed. First thing we're going to do is type node -- help. So here are all the options that we can run Node with. For here, we're not going to run them with all of them. We're just going to check a couple of them. So we're going to check the version now. We'll type node -v or -- version. And we see that we are running Node 6.3.1, the one we just installed. So let's make sure that Node works. So let us make sure that Node works. So we're just going to run it without anything, just Node. And we get an interactive prompt. So we can actually type JavaScript in here. So let's type some very basic JavaScript. Create a variable. And then we'll add a number to it. And we see that it returns 2. So we can see that Node.js is working. I'm going to press Ctrl D to exit out of Node. And now I'm in the directory of section 1.2, and inside of this, there is a file named test. And I will go ahead and output this, and you can see that this is pretty much what we just typed into Node. And now we're going to kick off Node with this file and see what it does. So we will call Node, and then we'll add the file that we want it to run. And we see it output 2. So it created A, it added 1 to it, and logged it to the console. So Node is installed, and we made sure that it is working. So in this video, we learned all about how Node.js releases work, what it means to be a current Node.js release, and what it means to be an LTS Node.js release. We then installed Node, and then we made sure that Node worked. Now in the next video, we will explore the Node.js REPL. REPL is a great way to try out code without having to launch an entire project. Hello, and welcome to Node.js REPL, which is part of the course, The Complete Guide to Node.js. In the previous video, we learned about how Node.js releases versions and what an LTS is. Then we installed Node.js and launched the REPL. In this video, we're going to learn what a REPL is, then we will launch the Node.js REPL, and finally, we will see how to build a project-specific REPL. So let's go ahead and get started. First, let's cover what a REPL is. REPL stands for read, evaluate, print, loop. Breaking this down even further, read is reading input, which is then evaluated, and then the output of that evaluation is printed back out. Finally, this is done again and again, so it is looped. So the question is, what is this good for? This is great when we just have something quick to do or to test. For example, a syntax question. I work in a few different languages, and sometimes when I jump between different languages, I forget a specific syntax in a language. Now, having a REPL makes this really easy to get a test going. Some languages force you to create an entire project just to test one line of code. A REPL allows you to test one line of code in, well, one line of code. So let's go ahead and use the Node.js REPL. So open up a terminal and then type node and execute that. This is the REPL. We can enter any valid JavaScript or Node.js commands in it. Now, we did do this in the last video. We made sure that Node worked by opening the REPL. Now here we're actually going to do a little bit more inside of it. So we can have it evaluate any expression. Now here we're going to do 1 plus 1. So type that in and then press enter and that'll run it. So here is a REPL in action. If we think about what REPL means, we can see how this worked. First, it read in the expression 1 plus 1. Then it evaluated it. After that, it printed it out. And then finally, it's asking me again. This is a loop. So that's our REPL. Read, evaluate, print, loop. Now normally when you create an expression, you set it to a variable. Here we just executed the expression. In a REPL, you can use the underscore and it will return the last executed expression for you. So another feature that we can use is that we can press tab at an empty prompt and it will show us everything that's available in the context. So let's do that. So there it is. We can see there's quite a bit in here. So we know that we can run any of these right now. It's available in our scope. Tab also allows you to autocomplete. So we're going to go ahead and type set in, press tab, and we see it autocompletes to set interval. And we know that's a function. Now to leave the REPL, you can press Ctrl+C twice, or you can press Ctrl+D, which I'm going to do now. And as you can see, it drops you out. Now the final thing that we're going to look at is using a project-specific REPL. So we're going to open up the file project-specific in the section 1.3. So looking at this code, the first thing we do is require the REPL module. Next, we're going to start it and say, run with the prompt of section 1.3. And then once we have that started, we're going to say set in the context a variable named section13. And then when we run that, it's going to log out loaded a module. So this is very arbitrary, but hopefully it shows you the ability that you can actually build a nice little REPL inside of a project. So in a project, you may have security, you may have database connections, all these functions and modules that you created before that you may just need to test something in that project. And instead of having to launch the REPL and load them manually, you can create a file that'll load them automatically for you. So let's go ahead and test this. So open a terminal up into that directory, and then we are going to execute Node with that file. So we're going to say Node, and then project specific. We press enter, give it a second, and there it is. So we can see that the prompt is section 1.3 as we specified. And if we press tab, we should see section 13 right here. So we see that variable's there in the context, and then now we will execute it, and we see loaded a module. So this shows how you can add stuff to the context and then execute them. So if this was an actual module, section 13 would already be loaded, and then we can use it right now. So that ends our video about Node.js REPL. Now in this video, we have learned what a REPL is, we've used the Node.js REPL, and we learned how to build a project-specific REPL. In the next video, we will learn that Node.js is just JavaScript. Hello, and welcome to Node.js is JavaScript. In the previous video, we learned what the Node.js REPL is and how to use it. In this video, we're going to see that Node.js is just JavaScript. We will see that Node.js is built using Google Chrome's V8 JavaScript engine. This means that we can write JavaScript just like we do on the front end, although there are some differences. Finally, we will see that Node.js is ES 2015 compliant. First, let's talk about what the statement Node.js is JavaScript means. Because it is JavaScript, you most likely already have experience using the language. There is not any new syntax to learn when writing Node.js. This is because Node.js uses the Google Chrome V8 engine. So technically, JavaScript executed in Chrome runs the same as Node.js. Let's look at some examples. First, we will create an array of numbers from 1 to 5 in both Node.js and Chrome. We will do it in Chrome by using the console. So let's go ahead and do that now. Here, we will launch Node, so we are now in Node. There, we created an array of numbers. We'll do that in Chrome now. Now, as you can see, these actually executed in exactly the same way. And in fact, if you look at it, the same exact output is given back to you. So now we're going to build a small function to get the smallest number from this array. First, if we try math min with that array, we'll see that it doesn't work. It doesn't work with an array. We need to feed it all the numbers to get a minimum from this function. But what we can do is use a reduce function and then have that run math min. So we're going to go ahead and do that. And there we had Node. It returned 1, which is the smallest. So there we ran it in Node, and we can see it returned 1, which is the smallest number in that array. We'll run it in Chrome now. It returned 1 as well. So we can see they're still executing in the exact same way. This means that we can leverage a lot of what we know about JavaScript in Node.js. There are some caveats though. First of all, Node.js does not have a document model. This makes sense because Node.js doesn't actually render HTML, and HTML is part of the document model. If we go into Node and type document, we see that it doesn't exist. Whereas if we went to Chrome and type document, we see that it does exist. Another main difference is that when using Node.js, we know the exact version because we have control over the environment executing it, which is not true when you're using Chrome. Or when I should say, another great thing about using Node.js is that we can control the environment that it executes in. We know the exact version of Node.js. When you write a website, you have no idea what browsers are going to use it. So many times you cannot write the latest and newest JavaScript code because we are not sure if it will work. Whereas Node.js, we know that it will because we control what it executes in. Another couple differences is that Node.js has require, which we have used before. It has a module system. As you can see, we type require in here, and it is a function that actually works in Node.js. But we do this in Chrome, and there's an uncaught reference. So it does not exist in Chrome, but it does exist in Node.js. There are more differences than this, but this is a good overview. For the most part, JavaScript runs the same in both, except for specific instances of functions and objects that only exist in one or the other. A huge one is document, only existing in Chrome, and another example is require, only existing in Node. Now we touched on being able to use the latest and greatest in Node.js. So let's look at some examples of actually being able to do that. So the first thing we're going to do is use an arrow function. So we're going to rewrite the function we specified before to find the smallest number to be cleaner. So let's put that in now. So we can see this ran and it returned 1, which it should. Now let's put that in Chrome. And we see that returns 1 as well. Now because we're using the Chrome V8 engine, we can use ES 2015 features. The problem is we can't put them in our websites because we don't know if Chrome is going to be the only browser going to our site. But again, with Node, we know that we have a specific version of Node running and can use these features. Now another feature we can use is the spread operator, which is 3 dots, and it takes an array and it spreads it out across. So when we run that here, it actually spreads it out and mathmin will work, and we see we get a 1. We'll do this in Chrome as well, and we see we get a 1. Now when you look back to see our original function, this execution here is much shorter and much cleaner. So this is kind of some of the features that you can get with ES 2015. Now this video is not a complete ES 2015 walkthrough, but I did want to highlight that Node.js usually does run the latest and greatest version of JavaScript, and you can use new features of the language in Node.js. So wrapping up, in this video, we have seen that Node.js is just JavaScript. We can leverage much of the knowledge we have about building front-end JavaScript in a browser. There are some caveats though. There's no document object model in Node.js. Node.js also has some different APIs that are specific to itself that are not in browsers. Finally, we use some new JavaScript language features, as Node.js is near the leading edge of JavaScript features. Because we control the versions of the platform, we can write the newest of the new JavaScript if we want to, and it will work. Now in the next video, we will look at the other major executable that is installed with Node.js. Now in the next video, we will look at the other major executable that is installed with Node.js, which is npm. npm is a package manager for Node.js. Hello and welcome to installing a package with npm. In the previous video, we learned that Node.js is just JavaScript. This means that it shares a lot with front-end development, but it has its own quirks. In this video, we're going to use npm. This is a package manager for Node.js. We will stay very high level and just see how it works by installing, using, and uninstalling a package. First, let's look at npm. npm stands for Node Package Manager. It is a tool used for managing all the packages in a Node.js project. As we will see in later sections, projects can get quite large and have many packages, but npm will make this really easy. First, let's run it and see what arguments it accepts. So we will open a terminal, and we will run npm. And because we did not give it an argument, it displayed out all the arguments that you can give it. As you can see, there's quite a few things that it can do, but for the most part, we are going to look at install and uninstall. And really, these are going to be the two arguments that you use 98% of the time with npm. So here we're going to look at the arguments that you can use with install. So we will do npm help install. And we can see this runs through all the possible arguments that you can use with install. Now there are quite a few things that you can do, but we're going to keep it pretty simple. So the next question that you ask yourself is, how do we know what to install? Well, there's a public npm registry that has packages available. So let's take a look at that. So this is the public repository of all the npm packages that you can install. Now, usually you'll either know what the package you want is, or you'll find it from a search here. Now the package we're going to install is Lodash. This is a package that has many utilities that come in handy. And if we look on the page here, all the way at the bottom, we can see that Lodash is actually one of the most depended upon packages. Now another great thing about this site is that when you actually look at the package here, it will show you some information about it, usually how to use it, a few things along those lines. So for example, here is how you could use Lodash. Now let's go ahead and install Lodash using npm. Alright, now back at our terminal, we will type npm install Lodash. When we let that run, this should install pretty quickly. Now there are a few warnings here, But these warnings are just here because we do not have this as a true Node.js project. So it's warning us that, hey, you do not have these fields in a package.json. We will talk about this in the next section. So now that we've installed this package, we should see in our folder a directory named node modules. Now all the modules we install are installed here, and then we can see that there's Lodash. If we expand it, we can see then that there are many files inside of this that have all the utilities that we are going to use. Now I would like to note here that you can also install packages globally. This is done by running npm install and then adding a -g at the end. Now what this does, it installs a package in a central location. So instead of being in the project, it's in one location that's shared with all the other npm packages. Now I do want to note that this most likely is an anti-pattern. You will really only want to install things globally that need to run system-wide. And to be honest, there are very few things that really need to run system-wide. It is much better to keep your dependencies tied directly to your project. Now, let's go ahead and use this package. So we will start Node, and then we will create a variable named Lodash, and we will say require Lodash, and then we will output this. So we can see here that this now has all of these utilities that are part of Lodash, and we can use it right here in Node. And of course, if this was a script, we'd put this at the top and we would have it available to the rest of the script. We will go ahead and leave here. And now we are going to uninstall Lodash. So we installed it, we now used it, and now we're going to uninstall it because we actually don't want this in our project anymore, for example. So it's pretty much what you'd expect. We'd run npm uninstall Lodash. We let that run, and then it's done. Now if we notice over here, we still have the node modules, but there's no more Lodash module underneath it. So it is completely gone. So in this video, we used npm and we learned about the npm package registry, where we can search for packages and see some information about them. Now npm is a tool that is used in every Node.js project, and we will definitely go into much more depth in the next section about modules. Now in summary of this section, we've had an introduction to what Node.js and npm are. We started off by installing Node.js. In addition to this, we learned about the release numbering and the release schedule for Node. Then we used the Node.js REPL. This is a great tool to test and validate ideas in code. There is very little setup and instantaneous results. Then we looked at what is behind Node.js, the V8 engine. This means that Node.js is just JavaScript, a language that most of us have already programmed in before. Finally, we used npm to install a package and then use that package and then uninstall the package. So this gives us a great introduction to what Node.js is at a high level. The next sections will go into further depth about how to use Node.js. Now in the next section, we will specifically talk about how modules work in Node.js. The module is the core building block in all Node.js projects. We will see how modules are loaded, how to create our own module, and how to manage a project of modules. Hello, and welcome to the Complete Guide to Node.js. This is section 2, and it's named Using the Node.js Module System. In this section, we will learn all about creating modules in Node.js. Modules are the core building blocks of Node.js projects. A module could be anything from a single file with a single function to a large directory covering many files. Modules are not too difficult, but we need to understand a few things which will make everything easier. So first, we'll learn about how modules load with require. Then we will see the basic way to make a module work with export, which will allow us to build our own module. Finally, we'll look at the important parts of the package JSON, which includes npm run. Now we'll start the section with this video, which will cover the require function and how it works. In this video, we're going to look at how require loads modules and any exceptions to this. So we're starting with require. We used it in the last video of the last section. After we installed a module, we loaded it with require. So what does require actually do? Require will take a file, a directory, an installed package, or a core module, and take everything exported and bring it into the current scope. We will cover how to export in the next video, so we will not focus on that here. We will focus on how Node.js determines what to load because it is very versatile. Let's first look at the directory setup. The directory is under section 2 and in section 2.1, right here. We have two directories and a file. The file is filerequire.js, and it has a single export that just states it is a file. Then we have a directory named our directory and finally node modules. Here's our directory and a node modules. Inside of node modules, we have an HTTP, a Lodash, and our module that is installed into it. Each one exports a different message, so we can be sure of which module has been loaded. So let's talk about how it should work, then show examples. There are 4 high-level resolutions. First is core modules. Anything that is a core module can just be loaded with require and the module's name. For example, OS. All of Node's core modules are listed in its API documentation. The next 2 resolutions come into play when a // or a combination of both are used. These indicate that we want to require something that is relative to us. First, it will check to see if it's a file, then a directory. Finally, require will check the node modules folder. In addition to this, we can load a file by just the file name. It will append .js, .json, and .node to find the file. We will only use .js as we are solely building modules in JavaScript here. So that was a lot of explanation. Let's actually load some modules and see how this works. So we are in our directory, and there should be a directory structure that I described before. Now launch Node.js by typing node. First thing we'll load is a core module. So we will load the OS core module. We run this. We didn't get any errors, so we can see what's in this variable. And we see there's a lot here. So this is a core module loaded, and we can use anything here in our application. Next, we will load a file, and we will load the file require that we have in our project right here. So let's try that by doing var file equals require file require. So as you can see, we talked about this before, that when you're loading a file or directory, you need to use a dot or a slash to tell require that you're actually looking for this file relative to where you are now. So let's go ahead and come back here and give it a dot slash to tell it look in this directory for this file. And we see it did not error now. And we output it, and it says I am a file, which is what we expected it to output. So we loaded it. Also notice that we did not give it an extension, and it still found it. So that was before when we talked about it'll append the .js, a .json, or .node to find this. So we can run this again and put a .js and see that it finds the file as well. Let's now load a directory. So let's type our directory, which we have here, and try to load it. We got another error. Again, this is because we did not add the dot slash. We add it, and then everything's fine. We output it, and we say, I am a directory. Now here, we are relying on the fact that require will load the file index.js inside of that directory. We can define index in the require. Now in a few videos we will discuss the file package.json and what it does. One of the things that it does is tell require which file it should use when loading it. For now we'll just make the assumption that it's looking for index.js. So we can load this again, and we will put the index.js and see that's what it loads. So that's actually what it does when it loads a directory, is it looks for a specific file. And again, in a few videos, we will talk about how to specify a different file than index.js. Now finally, we'll use node modules. Let's load Lodash, which we've done before. We see that it's the full Lodash module. We loaded it. Another thing to notice is that in the node modules, when we have a module installed, we do not have to put the /. Require will look through the node modules directory for a directory named the same as our require when it's installed there. So now we'll look at a few things that we need to know. First is that modules are cached. That means multiple calls to require with the same file will get the same object returned. Most of the time this is not a problem, but it is good to know that it happens. Second, what happens when we have a module that is named the same as a core module? What is loaded? Well, let's try it out. So as you can see in our node modules, we have a module named HTTP. And inside of it, we have this index.js that says I am HTTP. So what happens when we require this? So let's require HTTP. We see that it actually loaded the core module. So this means that core modules are always loaded first. And that's because there's an order that require goes through to determine what to load. So first is core modules. Those are always loaded over anything else. Then files, then directories, and finally it looks in node modules directory. Now, if we really needed that module and it really was named the same as a core module, we still can require it. We can do a / in front of it, and we output it, and we see that it actually loaded the one from node modules. So again, if we think about how that loads, there's no core module that's /HTTP. Then it looked for a file. There's no file that's HTTP. There's no directory that's HTTP. Then it went under the node modules and then found the HTTP directory there and then loaded that. So that's how we were able to load this directory even though it's named the same as a core module. And finally, just a few notes about node modules. So first, require looks in the project's root to find the module directory named node modules. So in ours, that's what we're doing. We're in section 2.1 and there's a directory in that folder named node modules. So if it is not found there, it'll then start going up the directory chain, meaning if it doesn't find it here, it'll go to this parent's directory and look for node modules there. Then if it's not found there, it'll go up the next directory and look for it there, and so on. There's also a global node modules, and Node will use this as well to look for modules installed. I feel that both of these are anti-patterns and should not be relied upon for a project. If a project needs a module, it should be in that project in the node modules directory. So that sums up our video. In this video, we have looked at the require function. It is the single most used part of Node.js when building a project. Understanding how to load modules is key. We learned the order require will use to resolve a module. Then we looked at a few exceptions to these rules. In the next video, we will see how to export from a module. This is the next logical step as we just learned how to require a module, so we will learn how to make this work. Welcome to Module Exports. This is the second video in this section. In the last video, we saw how require looks through the directory trying to find the file we want to include. In this video, we're going to take a look at how module.exports work. This is the other side of using require. So we will go over multiple ways that we can use module.exports and under what circumstances we would use each of these. First, let's talk about what module.exports actually is. When we require a file or module, we need a way to make the code in that file or module available to the object that required it. Node.js does that. Node.js does not run everything in a global state, and that is a good thing. Module.exports allows us to register variables that need to go to the outer scope or file. This gives us complete control over what is exported. So now we will look at some examples to drive this home. Before that though, we will look at the difference between module.exports and exports. We will see both used in this project, and it's good to understand how they work. First, module.exports is the actual object that is returned into the outer file. We can completely replace this object or add to it. Now in contrast, exports is just a helper object that will transfer all of its properties to module.exports. Now in my personal opinion, I like module.exports, as it is the most explicit and clear of what you are exporting. So, open up the directory to section 2.2, and there are a few files in here that we will load. So first up is simple.js, which I already have here. So we see that we set module.exports equal to a string. So let's go ahead and require that and see what happens. First off, start Node, and we will require this. And we'll output it, and we see that S is actually replaced as the full string here, simple module.exports. So we see when you use module exports and you replace it, whatever you put there is exported into the outer scope. Now let's contrast that with exports. So here is exports. So we will load this now. So we see that this returns an object with the property test set. Now you cannot just return a string using exports because exports transfers all of its properties to the module.exports object. You cannot replace it because then nothing will be returned. Again, this is why I like module.exports, because you have full control over what is exported. So we've done some simple exports. Let's see what happens when you need to export more than just one string. We will look at multiple.js. And let's require it. So we see that when you set the parameters, the properties of the module.exports, they get set to the object that gets returned from this file when you require it. Now you'll see that the first two I set as module.exports, and the third I used exports.third. So you can see that it takes whatever properties are in exports and puts it on the module.exports. So here we go. We see that you can return multiple things from a file. Now let's load something other than strings. So we have a function here, and you can see in here that we've defined two functions, and then we export those. And one more thing is that we require the multiple file, which we just looked at, takes the first property of that and sets it to the first property of what we export. So let's run this and see what's returned. So again, we see here that it has properties, and then we can run these. See, that returns a string, and we can see the property that was set from another require. Now I wanted to include requiring another file from a require in that many times this is how Node.js projects are built. You will have many files that just do one thing, have one function, one string, for example, and then you require them in another file, which is then required in another file. And then that is how you get a lot of little things together and you get all the functionality into a different file. So now we've looked at all the simple ways that you can export stuff using module.exports. Now let's look at some more complex examples. First, we will look at loading a class. So I've defined a class named point. It just has an XY. This is using the ES 2015 to define the class. So we have a constructor, and then we have one method, coordinate, which just outputs the X and Y. Now, to use this, we completely replace the module.exports with this class. So let's use this. So to use it, you will export it and set it to a variable. So now we have this. This is not actually an object, it's a definition of a class. So to actually use it, we will have to initialize it. And we see it returned a class. We can call methods off of it. There we go. Now because this is a class, we can initialize multiple copies of it. So we can create another point, and we still have the first point. So this is a great way to define a class definition once and be able to use it in many different places. We just create this file and we export that class as the module.exports. So we'll look at one more complex situation, and that's if we need a parameter in the file. And we have one named parameter. So this one is definitely the most complex. So what we actually return is a function as a module.exports that accepts a parameter. So when we require this, we can pass a parameter in. And then inside of that function, we return an object. Now the object that's returned in this function essentially takes the place of the module.exports. And we can define multiple properties. So if you see here, we define module, and then we put a name and a say hi on it. And these will be set depending on what is passed in to this function. So let's use this and see how this works. I will use Josh since that is my name. Now, because this is a function, we need to pass in the parameter right here. So I'm putting Josh here and executing it. Now let's see what is returned. So we see that we get that module object back with the name and say hi. And we see that everything is working how we expect it to. So the object that was returned is changed based on what is passed in. We can do this again and use Brian and see that the object is different based on what we passed into it. So we still have Josh, but we also have Brian. So this is a way that if you need something to change based on a parameter, you can actually pass it in from the outer scope into the file, do something with it, and then return something back into that outer scope. So this wraps up exporting objects. In this video, we have seen multiple ways to export objects from required files. We can have a simple export where we just set module.exports to whatever we want. We can export multiple items by creating them as properties off of module.exports. And these can be any JavaScript type, whether it's a string or a function or whatever we want. In addition to this, we can also export class definitions and use them in multiple places. And finally, we can even pass in parameters into the file, which then change how the object is created and sent back out to the outer scope. Now in the next video, we will walk through the properties of package.json and how they work. Welcome to package.json walkthrough. In the previous video, we learned how to use module.exports to export functions and variables from a file. This allows Node.js projects to be very modular. In this video, we're going to learn about the file package.json. This is a core file in any Node.js module. We will learn what it is, how to create one, and what we need to put in the file. As I've just stated, package.json is the core of a module. It defines the module and meta information about the module. It is the first thing that should be created when starting a Node.js project. Let's see how to create one. We will go to the directory section 2.3 and run npm init, which we'll do right now. That's the command. And it's going to ask us some questions. First off, it's going to ask us the name. And then as you can see, there are defaults in parens that we can use. Now, we can't use a capital letter for a name, so I will just give it a lowercase, give it that name. Then the version, description, the entry point, a test command, a repository, keywords, author, and a license. Then it's asking me, this is the package.json I'm going to create. Is that okay? I will say yes. So here is the package.json we just created. Let's look at these fields and see what they are. First up is name. This, of course, is the name of the package. Now, if we were to publish this on npm, then we would have to make sure that this is a unique name. Next is version. This follows semver, which is a definition of version numbering. Basically, it means that the version is major, which is 1, .minor, which here is 0, .patch, which is 0. Any breaking API changes require a major number change. Any functionality changes will require a minor change, but of course we can't break any API functionality. And then bug fixes usually have a patch version increase. This numbering system is also what Node.js uses to number their releases as well. Now with a name and a version, this is technically the bare minimum that you need in a package.json. Continuing on, description is used to describe the package. Here is where you want to put what your package does and anything about it that a user would need to know. Next is main. This is what tells require which package to use when loading this module. Now here it defaults to index.js, but if we needed anything other than that, we would define it here. Then we get to scripts, which is an object, and then each property is a specific script that we can kick off with npm. We will cover this in more depth in a later section. Then the author, this is where you put your name. And finally, we have the license. By default, it uses ISC, which is a very simple and permissive license. It's very similar to a BSD and an MIT license. Now we can't cover what's in those licenses, but I definitely recommend that you look that up and see what is in those. Now let's take a look at some other properties that we can use. Now I want to note that this is not going to be a comprehensive list, but it will be a practical list. So I have an example JSON in here that we will take a look at. As you can see, some of them are the same, but there are a few more new properties. So first one that's new is a repository. Now usually when you see modules, this is going to be a GitHub repo. Of course, you want to put wherever your repository is for this code. So this tells the user of it, this is where the actual source code of this library / module is. And if you want to make any pull requests, you can go here and do that. Next up are dependencies and dev dependencies. Dependencies is of course a list of dependencies. Whatever is listed here will need to be installed alongside this package for it to work. Now dev dependencies are similar, but they usually just refer to things like test runners and build tools. Technically stuff that is not needed for the module to work, but it is needed if you want to do any development on the module. Now we will talk about dependencies in the next video. Finally, there's a section on engines. Now here we can use it to tell the package to say, I will only run on Node that's over version 5. That's what this is saying. Now if this is omitted, it will assume to be able to run on any Node version. Now this may not be a concern, but if you're using specific features that only exist in a certain version of Node, you want to specify that here. So that does it for this video. In this video, we've created a package.json and looked at the required fields and some useful fields. In the next video, we will see how to use npm to install and manage dependencies. Hello and welcome to using package.json to manage dependencies. In the previous video, we looked at the properties of package.json, which is the core of any Node.js project. In this video, we're going to look at installing and managing dependencies. We're going to look at it in two different ways that we can do this. First off, dependency management is an integral part of any Node.js project today. There are many projects out there that do a lot of little things for you. This is great. We do not need to reinvent the wheel every time we do something that millions of other people have done. Node.js and npm have made this very trivial to add these to our project, as we will find out in this video. Now the first way to install dependency is something we have already done. We will use npm install and install Lodash. So let's do that now. Let's run npm install Lodash. Okay, it's done. It installed. We can come over here, look at Node modules, and see that we have Lodash. But let's look at our package.json, which is right here. As we can see that it is not in our package.json. Now, when we install a dependency, we want it to be in our package.json so that it is explicitly defined as a dependency. So here, we're going to rerun npm install Lodash, but this time we're going to add a -- save. Now notice it installed again, but this time it added Lodash as a dependency into the package.json. But what's up with that caret in front of the version number? Well, this is NPM's way of being able to match versions. We will go through all the different ways that you can match a version. I have these in an example package.json right here. So let's go through these. First is just using the version. Now this means that only that explicit version will be installed. Now next is a greater than. Now this works exactly how you think it would. Any version that's greater than this number will be installed. This also works with the greater than and equal to sign, the less than, and the less than or equal to sign. And these work exactly how you expect them to. Next is the tilde. This is an approximate version. This means that in our example of Lodash version 4.13.1, it will allow patch level changes. If the line was -4, then minor changes up to version 5 would be allowed. Next is the caret. The caret will match up to the leftmost non-zero digit. Now again, in our example of 4.13.1, this would install any versions up to 5, because that is the leftmost digit that is not 0. Now, if we had a 0 in the first position, so let's say we had 0.13.1, this would actually allow any updates all the way up to 0.14. Next is an X, and this means that any number can be put in place of wherever the X is. Now here we have it at the patch level, but you can put this in any of the spots. Then we have a star. This means any version will work. Next is using Git. So we have 3 Git URLs here. So if we look at these, first is just a Git repo. This will use the master branch by default. Next, we can specify a branch by putting a hashtag. So here, this says go to the Lodash repository and install the npm branch. And we can even install on a specific commit by putting the commit hash here. We can also use a relative file. Here, we're saying use file and then use this relative path to find that module. Now, one thing to note that this is not valid to upload to npm. You cannot use relative paths. And that's it. So there are many different ways that you can specify a version in the package.json. I would like to pause here and make a point that usually pinning a version, which means using an explicit version, is correct. If we are developing with a certain version and we know it works, it would make sense to install that version when someone else uses it. This would protect against any version changes breaking our module. Now next, we'll jump back to our package.json and we will install a package by using package.json. Let's go back here and copy out underscore and this dev dependency. We will copy it and we will put it in here. We just need a comma here. Okay. So this is saying that for this project here, we need Lodash and underscore installed as dependencies, and as a development dependency, we need debug. Now I will go ahead and blow away the current node modules. And now to install dependencies that are referenced in package.json, you actually just run npm install with no parameters after that. And we will do that right now. Give it a second while it installs. Okay, it is done. We can see here it said it installed debug, which relied on ms, and installed Lodash and installed underscore. And we can see that they are here by expanding node modules. Now one thing to note is that it actually installed all of our dependencies and the dev dependencies. Now if we don't want that to happen, I will go ahead and delete this again. We just run npm install, but this time we say -- only equals production. Run that, give that a second. We see that it actually only installed the production dependencies of Lodash and underscore. as we can see here. It's only there and specified here. So that is it for this video. And in this video, we've seen how to manage dependencies which are installed for our project. We saw that as we install them, we can put them into our package.json. Then we learned about all the different ways that you can specify the version that you want for that dependency in your package.json. And finally, we saw if you already have a package.json that specifies dependencies, how to install them. Now in the next video, we'll learn about a very useful feature of NPM that utilizes a script property of package.json, and that is npm run. Welcome to using npm run. In the previous video, we learned how package.json stores and manages our dependency for a module. In this video, we're going to use the scripts property in package.json to define custom scripts to run at certain times. Now these are ran through npm run. There are certain built-in scripts that look for certain properties, but we can also create our own if needed. So we have a package.json in section 2.5 that has a bunch of properties in the scripts object defined. So here's the package.json, and we're going to look at each one of these and when they run and how to run them. So the first one we're going to look at is test. Now this test relies on Mocha right here, which we have installed through our dev dependencies, and I have already installed. As we can see, it's here in Node modules. Mocha is installed. And in addition to this, it installs an executable in .bin. We see there's an underscore Mocha and a Mocha installed here in .bin. Now, one of the great things about running this script through npm run is that we don't have to define to go to .bin to execute this. By default, npm run will look in the .bin for these executables to run. So we can just run mocha tests, which we're going to run the test script by typing npm test. This is one of the special built-in ones that we can just say npm and then run test, and it will run the test from the scripts object. So we run it. It erred out, but that's okay because we actually don't have a folder test, which is what it's looking for. So it tried to execute Mocha, which it did, and then said I could not resolve tests. Okay, so it said test failed, which is exactly what we'd expect. Now the next thing we're going to run is start, stop, and restart. And again, these are all custom built in. We're also going to see how you can pass a parameter to these scripts. As you can see in start here, we say echo 1. So we have to pass something to it for it to echo. Now, when we run npm start, there's actually a few more hooks that'll run. So before it runs, it'll run pre-start, then it will run start, and finally run post-start. So let's go ahead and run this by running npm start, and then using the double dash, we can now pass in a parameter into start. So we will pass in test this out. And then run this. And there we go. So right here, echo the pre-start script. So echoed the pre-start script. Then we said echo 1, test this out. And we see that it echoed it out. And then finally, the post-start script. So these are how the hooks run, as I just described. We run pre-start, start, then post-start. Next, we're going to run npm stop and see that it runs the stop script, and npm restart. Well, I need to type it right, npm restart, and see that it runs the restart script. Now these are kind of the major scripts that are defined: test, start, stop, restart. And now the scripts we ran here are very arbitrary. A lot of times you'll use them with Node and run a program or a file that we've defined in our project. Now, let's look at custom properties. So we can define our own scripts to run that don't match any of these predefined properties that we've already seen. Here we've defined it as custom. Now what's great about this is that it also has the same hooks. You can run pre-custom and post-custom. Now to run a custom script, you type npm run and then the name of whatever the script you want to run. Now ours is going to be custom, so we'll type that in and let this run. So we can see that pre-custom script ran here, the pre-custom script, then the custom script, and finally the post-custom script. So as we see, we can define whatever we want and run it by typing npm run and then the name of the property that we define. So now that we've seen that you can run built-in scripts and also custom scripts, why add them? Well, first off, the built-in ones kind of make sense. If we create a web application, how do we start it? Well, you run npm start, and that should start the site. We want to test it, that should be npm test. Makes sense. We want to stop it, npm stop. The others, it's hard to say. It's not quite clear. Now let's say, for example, we built a site in TypeScript. Now TypeScript is a superset of JavaScript that you can program in, and it compiles down to JavaScript. So there's actually a compilation step. Now, when we go to run or publish this, we want to run the TypeScript and turn it into JavaScript. So that'd be a perfect way to add a script here to run that on those hooks. Now, the cases and things that you can do are innumerable. So we can't run through every possibility that you could have that might need a script. But knowing that you can create a script that you can reuse inside npm and inside the package.json, and it comes with your package, is great. Now in this video, we have seen that the scripts property and what it does in your package.json. It works right alongside npm run, and we can use predefined commands like test, start, stop, restart, or we can completely build our own custom events and commands and run them along with it. Now in the next video, we will use everything we learned and build our own custom module. Welcome to creating our own package. Now in the previous video, we learned how npm run works and how it works along with the scripts property in package.json. In this video, we're going to build our own package. Now this takes everything we learned from the previous videos in this section and applies them. First, we will start off by looking at the package.json that we're going to use for our project. So as you can see, we have a name of packed math, we have a version, we have a nice description, and then the main specifies a different file than index.js. Then we have a scripts that specifies a test. The author and license are not that important because it's just an example library. And then we have dev dependencies, which specifies Mocha, which we need because we're using Mocha for our testing. And then the dependencies of math.js, which we'll learn why we need that here shortly. So I'd like to point out that we're going to build a library module. This is something that'd be used in making another project, but it doesn't actually have an application to execute. So this means that we do not need a start, a restart, or a stop in the scripts object. So let's look at the actual code that this does. We're going to create an add and subtract. So let's look at those right now. We'll look at add. Very simple. We define an add function, just adds x and y, and we export it. We look at subtract. It does the exact same thing, except it subtracts them. Now we can see the math.js. Remember, this is the main entrance to this library. We see that it requires add and subtract, and then exports them. So remember back to our previous videos when we talked about requiring, when sometimes you would require another file and then immediately export it. So this is a good example of that. So we've defined simple modules in add and subtract. They just have one function in them. And then we have this file, the math.js, in which we want to export everything in this library So we require them in the math.js, then we export them. And we can see that we use math.js here to get pi, which we'll look at in just 1 second. But before that, we want to make sure that our add and subtract are working correctly. And we do this by creating tests. So as you can see, we're going to run mocha tests. So this says run mocha against the folder tests, which we have right here, and we have a test in it. And we have as a dependency mocha, which is already installed. So look at tests here. Now, without getting into too much of what mocha is, this is how you create a mocha test. So we're going to require assert and in math, which it says go up one directory because we're in tests, and use the math file here. So this has the add and subtract. So in here we test add. So we add 1 and 1 should be 2, 0 and 10 should be 10, -1 and 1 should be 0. Then we do the same thing with subtract. 1 and 1 should be 0, 10 and 5 should be 5, 1 and -1 should be 2. Now to test this, remember we've defined it in our package JSON. We just type npm test. So we'll go ahead and do that right now to make sure that our add and subtract are working correctly. And there it goes. So it tested our code and came back with 2 passing. So all of those tests pass. So we trust that add and subtract are working exactly how we expect them to be. So now we're going to pull in pi. So we have this here, math.js, and we're going to pull math pi from that and export it as pi in our object. And again, we've added it as a dependency. Now this is a direct dependency. So for the module to work, math.js needs to be installed, which is different than mocha. If you're just using the library, you actually don't need mocha. You only need math.js. But if you want to develop and create tests for it, you will need mocha. So it is added as a development dependency. So at this point, we have a complete module. So let's test it. So we will run node, and now we will require the module we just created. We'll say, grab the math.js file, which has everything in it. There we go. And run math. And we see we have add, subtract, and pi. Now we tested these, but of course we can do them here. So we're going to say 3 and 1. That's 4. We can go the other way. We'll say 4, subtract 1, should be 3. We'll look at math pi. There we go. We have a working module that we created from scratch. Now again, thinking through everything we learned, we can see how the package JSON actually has everything you need to know about this package. We have main, which tells you which file to start with. Once you're inside that file, you can actually then use the requires to figure out what other files are being used. We have scripts that define anything that anyone using the project or developing with the project would need to know to make it work. And then we have dependencies, which show anyone else using this project what this project depends on. So as we can see, this video is a culmination of everything we learned in this section. First off, we learned how files are required and how require resolves any file names or modules. Then we learned how to export items out of files. After that, we learned what a package JSON is and what the properties are inside of it. Then we learned about npm run and how it works with the package JSON. And then finally, we took all of those, put them together, and built our own package. Now, in the next section, we will learn about some specific Node.js paradigms. This is important as Node.js is an asynchronous, non-blocking I/O server. If you don't know what that is, or you've never programmed in Node.js before, other than what we've already covered here, there are definitely a few things that can lead to bugs in your code and issues. We will discuss what those are in the next section. Hello and welcome to the Complete Guide to Node.js. This is the third section where we will discuss useful Node.js paradigms. Specifically, we will look at what asynchronous means in Node.js, how the event loop works, how to use callbacks effectively, what promises are, and finally, how to handle errors. Now in this video, which is how Node.js is asynchronous, we will look at non-blocking. Now we use this phrase in the first section and we will now discuss what it is. This leads us to run a few functions to get a better feel for asynchronous execution. Non-blocking, what does that mean? It means that certain calls do not block the thread. So going even further, what does that mean? Let's use the example of opening a file. In this example, the process that wants the contents of the file does not wait for the file to open. This means the thread is not blocked, or non-blocking. The opposite of that is where the thread will wait until the file is open before continuing. So that is really what the breakdown of what non-blocking is. Now this may lead to the question, isn't opening a file fast? Well, yes and no, depending on the context. Opening a file on the local file system is essentially imperceptible to a human, but it does take enough time that the CPU can do other things while waiting. This time can be even more pronounced if the file being opened is on a file share across the network. Now we're talking about taking a second or more of waiting to open the file. For the CPU, which can do upwards of 2 billion plus operations per second, waiting 1 second is a long time. Now this is also true for things like running a database query, responding to a network call, and many other things. So really, breaking it down, non-blocking I/O means that the thread is not blocked by any I/O resource operations. So to drive this home, we are going to look at some code. First, we will write a synchronous function and run it. This should seem very familiar for anyone that has written any JavaScript before. So let's look at that now. So in section 3.1, there should be a file called async.js and then a test.txt. We'll take a look at the test.txt. We see it just says this is a test file. And in async, we use fs, which is for file system. We have two variables, file A for file asynchronous, file S for file synchronous. So first off, we're going to do the synchronous, which is right here, read file sync. We have the name of the file, and then we're going to encode it. We're going to say it's UTF-8 or ASCII, and then we're going to log out the value of that variable. Again, if you've ever written JavaScript before, this seems very familiar. We set the value of the variable to the output of this function, and then we output that variable. So let's run this and make sure it works how we expect it. Again, that's node async.js. I'm in the folder. We'll run it, and there we go. So it output what was in the file. This works exactly how we expect it. Now let's do it asynchronous. So I had the code commented out before. I will uncomment it here. Save it. So let's look at this. Now this uses a callback. So we are using read file right here. We pass in the same parameters, the file name, UTF-8. The difference is we are now running a function. So we're saying when you are done opening this file, run this function here. Now, we will not go in depth about callbacks here because we will cover them in depth in this section. So just know that this is called when the file is opened. Now, outside the callback, we will then do a console log of that variable. So here we're saying open and read the file, set file A to the data that comes out, and then log the output of that. So before we run this, what do you think the output of this console log will be? I will comment this one out so that we will just have the asynchronous. Let's run it. It was undefined. This is because the CPU essentially said, while you are opening that file, I will continue on down with the program. So this said, oh, you wanted to open a file? The CPU said, okay, well, I will register to do that when it's open, and then I will now log the output. And because this code right here had not run yet, this was undefined. So this is what non-blocking is right here. This blocked. This call right here blocked. It said, oh, you're opening a file. I will wait until the file is open. Then I will set the value of this, and then you can output it. Here said, the CPU said, okay, you are opening this file. I will come back to it, and I will continue on down. Now, I have this set timeout here, and this will wait 100 milliseconds. This should be more than enough time when opening a file on the local file system. So we will save this, and we will rerun it, and we will see what the value of that is. Okay, so this undefined was our console before. But now, we waited 100 milliseconds, and then logged the output of it, and we saw that it outputted the file. So this shows that this code here ran at some point between here and 100 milliseconds after here. So this is what I mean when I say that Node.js is asynchronous. Now, I do want to note that setting a timeout and trying to get the value like that is a horrible way. You should not do this in production. I just did this for a demonstrative purpose. We will definitely cover what you need to do in this section. And in fact, that is what this section is about. How do you deal with the fact that Node.js is asynchronous? So ultimately, the reason why Node.js does this is that makes Node.js very concurrent. And this means that it can handle many things at once, although it isn't technically a true parallel. Now in this video, we have covered what non-blocking I/O is. We then looked at a blocking and a non-blocking function to see what the impact is on our programming. Now in the next video, we will look at the actual mechanism that makes Node.js non-blocking, the event loop. Hello and welcome to the event loop. Now in the previous video, we looked at the fact that Node.js is asynchronous and how that affects linear code. We will now see how and why Node.js is asynchronous. We are going to do that in this video by looking over the event loop. First, we will discuss what it is and then run some examples. We say that Node.js is asynchronous because it uses an event loop to keep track of what it is waiting on to run. If we use the same examples of actions that take time to execute, for example, file reads, database queries, waiting for network data, we can then understand what the event loop does. First, let's contrast that with how other languages or frameworks or software deal with the blocking call. Now usually they just halt the program and wait. Now this is done if the application is single-threaded. Now if the application can kick off another thread to handle the blocking call, it'll do that. Now this does have some overhead involved and also adds some complexity when programming. Now doing either of these things are not necessarily wrong, but these are not how Node.js works. Another thing to keep in mind is that that is greatly simplified in how other applications handle blocking calls. Now Node.js has a single thread where the event loop runs. What this means is that code executes, and then when something needs to run later, it is put into an event queue and then handled later when it is ready. In our examples, we will use a JavaScript function setTimeout. Now this is not a perfect example of a blocking call, as it just registers itself in the event loop, whereas a true blocking call is implemented a little bit differently, as it waits on the I/O resource. Now we will not go to complete depths of how this works, but just know that setTimeout is a good demonstration and example of what actually happens when a blocking call is made. So let's write some code and then run it. So in the folder section 3.2, we can open the file index.js. Now inside of there are some functions that log to the console. First, we log right away with the time, which is right here. Next, we'll set a timeout for 1000 milliseconds, which is 1 second. Now this can be thought of as a blocking call that will take 1 second to execute. Then we do a while loop that will run for 4 seconds. So what do you think would happen if we run this. Let's go ahead and run it. There's the first call. Now a second has passed. We'd expect it to run. And there. Now the set timeout ran. And as we can see, there was a 4-second difference, 53 to 57. Now why did that happen? So this happens because this set timeout registers a function to run in the event loop for 1 second. This while actually will completely block the CPU, so nothing will happen for 4 seconds. So this set timeout put it in the event loop. This did not allow the CPU to go back to the event loop, and then once it was over, it went back to the event loop. It went back to the event queue and then found the set timeout and ran it. And then we had the output. Now let's do another example that may show this a little bit better. There's a file called blocking.js. Now this is going to do an actual blocking call. And of course we're going to run it asynchronously, which is opening a file. So we use the module fs again, which is for the file system. The first thing we do is output the milliseconds when we start to read the file. Then in the file read callback, we output the milliseconds when the file read is done. Then we do a set timeout to run in 0 milliseconds. And then finally, we do a final log. So don't run this just yet. What order do you think the logs will run? Now, it's a given that this will run first. What do you think is next? Do you think it will be the end file read? Do you think it will be the event loop from the set timeout? Or do you think it will be the after event loop? Then which one? And then which one? So we have 4 console logs. We know this is first. What's the order of the next 3? So let's execute this and find out. Alright, so there it is. We have the start read file. Again, we knew that was going to be first. And then we have the after event loop, which is actually the last console log we have in the file. Then we have added to event loop, and the final one is the end read file. So why did they run in this order? So first off, all direct statements will be executed in order. So the first one is console log. This executes. Remember, this says, hey, I have a function. It needs to be thrown into the event loop. This says I have a function, it needs to be thrown in the event loop, and then this says I need to do something now. So that's why after event loop executes second. So these are the 2 direct statements that are executed immediately. Now we do a set timeout and we say wait 0 milliseconds. Now that does not mean execute now because this function is still put into the event loop. And then the next time the event queue is checked, it says, oh, this one's ready, and it executes. So that is why it is executed third. Now finally, the asynchronous file read is executed because it takes the longest. So once the file was open and read, then it executed the end read file. And if we look at here and look at the difference between these numbers, we can see that it actually took 6 milliseconds for the OS to open the file, read it, and then execute this function. Now, depending on your computer and what exactly is going on with it, this could be anywhere from like 1 to 7 milliseconds for this to actually happen, to open a file and read it. So hopefully this shows a good example of how the event loop works. You have things that execute now, that will execute immediately. Then you have other ways of registering stuff to say, I will execute at a later point in time. Now, with something like a set timeout, you are explicitly defining what that later is, whereas if you're using an I/O resource, you are not sure, but you still can register a function to run at that later point in time when the I/O resource is open. So in this video, we have looked at the why and the how of Node's event loop. This is an important piece of information to understand and will increase our ability to troubleshoot issues and bugs. In the next video, we will break down Node.js's standardized callback pattern. This pattern is used by many core modules and even more modules from NPM, so it is important to understand how it works. Welcome to the video, The Callback Pattern. Now in the previous video, we learned about the event loop. This helps us understand what is happening when we try to open a file or make a network call, and a function is executed at a later point in time. In this video, we're going to take a look at the callback pattern. This is closely tied to the event loop. Now that we have an idea of what the event loop is, we can see how callbacks operate. If you have ever used any browser-side JavaScript, you've most likely used a callback. It is a function that is registered to run at a later time. It is called back, if you will. A perfect example of this is an AJAX call in the browser. The data returned from an AJAX call takes some amount of time, and we register a function to handle the data when it is returned. The same is true in Node.js. Essentially, everything in Node.js is going to happen at a later time than now. So we need to register a callback. We have done this already in some of our code, but we have not discussed the callback signature. This is a form of having an error as the first parameter and then the data as a second. Almost every core Node.js module follows this pattern. Let's write some code to see how this works. Using the read file functions, we will try to read a non-existent file and see the output of the variables in a file that does exist. Let's look at the code. This is in the section 3.3 directory. Now there is a file called callback.js. So in it, we use file system, module, fs, and we read a file. This one doesn't exist. This one exists. And we have error as a first and data as a second. And then we just log everything out for each one to see what happens. So let's see what happens. We will call it. So as we can see, if there's a problem, the error variable is defined. So here's non-existent and here's the error variable that is output. And the data is undefined. Now the opposite is true if we have a file that does exist. So error is null, and then this is the actual line that is in the file. So this is a little different from synchronous languages. Usually there's an exception thrown. It makes sense that exceptions are not thrown because it is asynchronous. With exceptions, you get the error before the code continues, but that is not true in Node.js. We could execute code and have an error, but then we could have more code execute before that error is returned. So this is why we need it returned in a callback. Now this means that we always need to check the error variable in all callbacks. So we have to put a boilerplate check to see if that exists and return that. So far we've only been doing one callback, but there are times when these need to stack. For example, we have to make a network call, take that data, then make a DB query, and then take that data, and then even make another query. So we will mock this up using files to replicate what we just discussed. So let's look at that. There's a file called multiple callbacks. So inside of this, we will run 3 callbacks. If we look, we're going to first call the network callback. So here's network callback, and this is just the path of the next file. So we'll take that, go to first DB query, then second DB query, and then this has data. So looking at our function again, we have the first file, which will be network call, which is called here. Then the data comes back. This will be first DB query. This will be second DB query. And finally, this will be the data of that file. So here we are executing 3 straight asynchronous functions that each have a callback. So let's go ahead and see that working. So we will run node multiple callbacks. And we see we got the data out. Now we didn't see all the internals in every step here, but we know that worked because we passed a network call and we got out the value of our second DB query file name. So what happens if we put a non-existent name as the first steps? So let's do that. I already have this set up, so we'll comment out this one, and we will run non-existent. We'll save this and see what happens. We run that. Now we did get an error, but looking at it, we really don't know what happened. It just says that we can't trim undefined. And it's undefined because we gave it a non-existent file. So it tried to read the data, and that data wasn't there. And it tried to trim that, and that threw an error. But we really don't know what happened. This is kind of a generic error. So let's look at code with error checks. So this is our multiple callbacks. Now here are error checks. So looking at this, it is set up the exact same way. We start with the first file, then we run 3 checks, and finally run the callback. Now here, as we can see, we say error, and if error, we execute the callback with the error and data as null. And then we have to do this for every execution, because any one of these could have a non-existent file. There could be an issue. And actually looking at this, I see a problem here in that this should be null, comma, data. So we need to do the opposite if we're going to execute that callback in the same way with no error and actual data. So let's call it with a non-existent file. So we're saying multiple callbacks error, non-existent, with an error and data, and we're going to log the error. So we will save this, and now let's execute it. So here we go. We actually have the error. This is so much more helpful. It says no such file or directory, and it even gives us a path. So we know exactly what went wrong. Previously, it just said we can't trim undefined, which doesn't mean anything. But this gives us explicit meaning, and we can track down the error. The downside to this is that it is a little hard to follow what is actually happening in this code. The lines start heading more and more to the right. Each function is indented. There's a name for this, and it's called callback hell. Now callbacks are great if they are one level deep. They do not stack well though. With the tools we have discussed so far, we do not have a great answer to this. This is something to keep in mind when writing Node.js code. In this video, we've looked at how Node.js uses callbacks to send errors and data to the caller. This is an important concept as almost every core Node.js module does this. Knowing how to handle this pattern is important. In the next video, we'll look at a tool that can help tame callback hell, which is promises. Promises help make asynchronous code seem synchronous. Welcome to promises instead of callbacks. In the previous video, we looked at the callback pattern. This is a pattern that is used in almost every Node.js module. In this video, we're going to take a look at using promises to help make all the callbacks more manageable. First, we'll look at what promises are exactly, and then see how to use them over, or more correctly, with callbacks. This will not be a complete coverage of everything promises can do, just how they can help make our code cleaner and easier to understand when using callbacks. In the previous video, we demonstrated a problem with callbacks, commonly referred to as callback hell. It is where there is a callback inside a callback inside a callback inside a callback, and so on. This is not an esoteric problem. This happens a lot. Think about how many times you have ever needed to make multiple queries or read a file and then do something with the result. It is very easy to need multiple levels of callbacks. This is where promises come in. A promise is a promise that data or an error will be returned. With that promise, you can then create functions to handle if it was a success and if it was a failure. Promises work great in asynchronous code because they make it appear synchronous. Let's look at some examples to see what this means. We will use the fsReadFile function again. It uses the Node.js callback pattern, which will return an error or data. We also do not know when it will finish executing. In section 3.4, there is a file promise_readFile. This demonstrates using a promise. Now a promise has two functions, resolve and reject. These allow us to control what happens to the promise. Looking at read file, We will reject the promise if there's an error or resolve it when there's not an error. So as we can see, this actually functions synchronously. So we're saying read a file by using fsReadFile here, but we are immediately returning a promise. So instead of waiting, we synchronously return the promise from this function. Then we execute our asynchronous code. And then when that returns, if there's an error, we call the reject function, which comes in here, or the resolve function, which comes in here. So how do we use this? This doesn't help us to actually see how to get the data or the error. So, as we can see, promises are returned. Then we use that promise to get access to the data. This is mainly done by the function then. Promises turn function calls into sentences, get the contents of a file, and then the function we use, which is called then, do this with it. Let's take a look at a simple example. We have that in promise.js. It uses a function we just created and exported to create a promise-based read file. We then use that with the function then, as you can see here. So this returns a promise. Then we use the then function on that promise. So this function accepts two parameters. The first runs on resolve and the second on reject. So this function here that's defined runs on resolve. So resolve, we call it with data. So this will be called with data. And again, this is demonstrated here. Now here, I'm not using the second function, so it is null, so nothing happens. But if we do define it, then this function will be called on reject here. So as you can see, resolve executes with data, reject with error. And to get access to those, we use the first function as resolve and the second function as error. So let's go ahead and run this and see. So we should see two returns, one with an error and one with data, and they will be prepended with either data or error that maps to each one. So this is node promise.js. There we go. The error returned first because it found that there wasn't a file. So as you can see, we have an error and a data. In just 5 lines of code, we are handling data or errors very easily, and even without any breaks or ifs inside of here to say if there's an error. We just say error, run this function, data, run this function. Already, we should see the value in this. We can write nice, clean, short functions, but actually, there's more. Let's look at a multiple promise chain. This is where things get even better. So we have a file multiple promises. This is similar to the file we looked at last section. It has 3 file reads that will eventually return the data we want. When using the then function, we can return another promise from it and make a chain. We are returning a chain of 3 promises which will open the 3 files. Compare this code to the previous code. Here, it is just 5 lines. The previous code was 21 if we're handling errors, which we should. Also, think about how this reads. Open a file, then open another file, then return the data. The other great thing is that if a promise is rejected, it will flow through a promise chain until someone handles it. Here, we do that by calling our function with a non-existent file. The first file read will fail, but we can handle that at the end. So let's run this and see what's going on. So there is our function. It's only 5 lines. We call it with network call, which is a valid file. And we take that promise and say if there's data, output it. If there's an error, output it. Then we call it with non-existent. And if there's data, output it or an error. So as we can see, this non-existent will actually fail this first promise read. But it will flow all the way through till we handle it here. because each one of these are only handling the data portion. So let's run that. And there we go. So here's our error. We get the error object out, and then here's the data we care about. So we can see we are easily handling the data and the error, whether there's actual data or an error, easily. Now, again, to reinforce a point, this is much less code and also easier to understand. In addition to this, we are making asynchronous calls synchronous again. So here we're saying multiple promises and then do this. Now, instead of worrying about when something will return, we have an object that will return the data and allow us to use it. In this video, we have learned about promises and how they can simplify complex asynchronous tasks. We wrap the task and then resolve or reject the promise based on the return. We can then easily use it by using the then function. I recommend doing more reading on promises as they can do way more than what we've covered here. We have just specifically looked at how they help us when using callbacks. Now in the next video, we will look at some error handling in Node.js. Welcome to error handling. In the previous video, we learned about promises and how they make asynchronous calls much easier to handle. In this video, we're going to talk about errors and how they can be created and how we should handle them. Errors will happen in every program. How we handle them is important. Node.js is no different. Not handling errors correctly can create bad user experiences. Even worse than that, we could open a vector for an attack by giving out details of how our application runs. Not handling errors correctly can create bad user experiences. Even worse than that, we could open a vector for attack by giving out details of how our application runs. This video will talk about different ways that errors are thrown in Node.js and the best way to deal with them. First up is synchronous errors. Even though we spent a lot of time talking about the asynchronous nature of Node.js, there are still functions that execute synchronously. A great example is using json.parse. This call will wait and return the object before continuing. When there's a string, it's not a valid object. What happens when the string is not a valid object? An error is thrown. We need to wrap the code in a try-catch. Now in section 3.5, we have a file errors.js, which I have open here. And then we will get to these next two, but this is the first one that we talked about, a synchronous error. We need to put a try-catch and then handle the error here. Now here we're just going to log it, but in your code, you'll have to decide what you need to do with any of these errors. So here we have our synchronous code, and then this will try to run, and if there's an error, it'll be caught here before continuing on. Next is handling asynchronous errors. We have touched on this in our other videos, but we will cover it here for completeness. When making an asynchronous call, most Node.js calls allow you to add a callback. This callback will receive an error as the first parameter. This must be checked. It is very important, as not checking for this will silently swallow the errors. This is very bad and leads to very hard to debug problems. Let's look at an example of this in the errors file. Again, we just did this in the last video and the one before, so this should make sense. In the callback, we have the error as the first variable and the data as the second. So we always need to check if error is set, then we need to do something with it. Finally, we're going to cover errors from event emitters. We have not covered event emitters, but we will get to them shortly in the next section. Event emitters need to have an error handler registered on the error event. Event emitters are essentially always running asynchronous functions. For example, opening a network connection. A network connection becomes a stream that every so often fires an event that says, hey, I have some data. Now, if an error happens, we need to know that as soon as possible. This is why we need to register an error handler to say, hey, an error happened. Let's look at this in the file. So here's the event emitter. We're going to use a network and we're going to create a server. Again, we will talk about this in future sections, but just know that this creates an event emitter. Then we say on the error event, capture that error and then do something with it. So let's run all these examples and see all the errors that happen. Now there should be 3 errors. So we will call node errors.js. Alright, so if we go up to here, we say first syntax error, unexpected token O in JSON at position 1. So that was the JSON parse trying. We captured that error and then we logged it to the console. Next is this error. No such file or directory. It doesn't exist, and we output it here. And that was because the error variable was set. Finally, we have this error. This essentially says that I do not have access on my computer to listen on port 80, but it is still an error for the create server. So here we said on error from the server, log it to the console. Now I felt this important to highlight here, as in tutorials it is hard to show errors as everything is set up to work. In addition to this, many times tutorials do not even discuss ways that things can go wrong. I wanted to show how to handle an error for each way it is created in Node.js. To summarize, we handle synchronous errors with a try-catch. Then we handle asynchronous errors by checking the error variable in the callback. Or, if we want to make this easier, use a promise. Finally, for event emitters, we just listen for the error event. Now this is the end of the section. So, to summarize what we've learned in this section, is that we have seen how Node.js uses non-blocking I/O, which makes most calls asynchronous. If you have never built anything asynchronous, this can lead to problems. We then learn the mechanism behind the asynchronousness, which is the event loop. We created some functions to see when and how they would execute. Next, we covered the callback pattern of passing the error first and then the output of the call second. After that, we learned how promises can reduce the amount of code written and make it easier to understand when using the callback. Finally, we looked at how errors are created and how to handle them. So we have learned quite a few useful Node.js paradigms in this section. In the next section, we'll learn about events. This is important as many of the most useful modules like network and HTTP use events. Welcome to the first section of Volume 2 of the Complete Guide to Node.js. In this section, we will look at events and see how event emitters work. Previously, we had dwelled on the asynchronous nature of Node.js, and this is actually an extension of that. We will look at event emitters and what they are, then add and remove events. Finally, we will learn how to create our own events. In this video, we will be discussing event emitters. We will cover what they are, why Node.js uses them, and a quick high-level overview of how they work. The first part of this video series, we covered handling asynchronous actions, as this is how Node.js works. Event emitters are just a continuation of this idea. Let's compare opening a file versus opening a network connection. A file has a set end. It is the end of the file. When the file is finished, Node.js kicks off the callback with the data. Now think about a network connection. This does not have a specific end. In fact, a network connection can stay open for a long time. How do we get data out of this then? This is where events come in. Every so often, a data event will fire and we can handle a chunk of data. To do this, we have to register a function to handle the events. The same idea is true for errors. With a set end, an error can be passed in as a parameter at the end in the callback. When there is not a set end, then it becomes an event. In fact, if a module has an error event and it does not have a listener, then an exception will be thrown and crash Node.js. It's important to understand how events work and how to handle them. In Node.js, almost every module sends some events. We can find the events in the API documentation for Node.js. We are going to focus on stream events because this is where Node.js really shines. A stream is essentially a stream of data that has chunks of data that is made available over time. This fits perfectly in Node.js with its event. We will cover streams in depth in the next section. Now let's look at some simple examples. Open section 1.1 and then find the file events.js. So here we're going to read a file using a stream instead of a callback. First, we create a stream from a file. Then we'll set listeners on open, data, and close. Each of these will fire when the event occurs. Now this is even more control than we had with a callback. Now one thing to remember is that with the data event, it will be called with the entire contents of the file, as the file is not very big. Now if the file was large enough, this would be called multiple times. Now each event is then just going to log to the console essentially what is happening. Either the file is open, it's closed, or the data that was actually returned. So let's go ahead and run this and see what happens. I'm in the directory. I will run node events.js. And there we go. So we can see file's open. That's the open event. Here's the data event, which is the contents of the file, and then the file was closed. So again, this gives us a lot of control, and we can put hooks on specific steps. Again, as we can see, this gives us a lot of control, and we can put hooks on specific steps. In this video, we've introduced events. Node.js is great at handling streams of data, and the best way to work with streams is with events. In the next video, we will look at all the different functions we can use to listen for events, whether that's adding events or then removing event listeners. Welcome to adding and removing events. In the previous video, we looked at what events were and how Node.js uses them. Essentially, events are asynchronous callbacks that have an indefinite input. In this video, we're going to look at how to manage adding and removing events. We will use all the important event management functions in this video. First thing we want to do is open up the file for this video. It is events.js in the directory section 1.2. This file will have a line for everything we are going to do in this video. So once we have that open, we will need to get a reference to an object that will emit events. We'll use the same object as the last video by running create read stream. So the first method we will look at when managing events is on. Now, if you have ever written any jQuery, this is a familiar method. We give it the name of the event and also the function to run when that event fires. So this event can also be added more than one time. So this method can be ran more than one time to add multiple listeners. So let's look at that, and then we'll run it and see how this works. So here we get the object file stream. This will emit the events. We're going to use this as one of the listeners, and here's how we use it. So the object on the event open, we run this listener. And we can do it again. So on open, run this listener, which we are defining the function in place right here. So it'll say file is open, first listener, files open, second listener. Then another event we're listening for is data, and then we will just log out the data. So let's go ahead and run this and see these listeners in action. So go to the console and run node events.js. So here are our listeners. First listener ran, second listener ran, and then here's the data listener. So this is on working. You just give it the name of the event, and then you give the function for it to run. Now, if you want to know what events each emitter has, this is where the Node API documentation comes in. It will tell you every one of the events that will fire. So the next method we will look at is once. This is just like on, but will only run once, then remove itself. So let's take a quick look to see how this works. So we will uncomment here, and then drop down to here. So this is a new code. Now, it's going to be hard to tell if a certain event is only going to run once. So we're going to fix that by calling the event with emit. Now, all we have to do to call emit is just give it the name of the event. So here, we are saying listen on close, and then we will emit close, and then close will also be emitted when the file is closed. So we're actually going to fire it twice. One time we will do it, and another time the actual object will do it when the file is closed. So first thing, let's see the difference if we just call it with on. So we'll run it, and there. So we see it ran twice, once here and then once here. So the event was fired twice. Now a question you may have is, why is there one at the top and one at the bottom? Now the reason for this is because Node.js uses event loops. So remember back when we talked about event loops, when you have a synchronous call like this will actually fire before any asynchronous call like this on. So we set all our listeners in this event loop, and this emit is also in that same event loop. Then when the file's open, read, and closed, these are all fired at a different time. So this is our explicit call to closed, and then this is the one that the object calls. Alright, so now let's actually change this to just be once. So if this works, we should expect it just to fire once and not twice. Make sure this is saved, and then run this, and there we go. So the last one is not ran. It was called once, and it removed itself. So once is well named. Now we will look at some event inspection methods. So if we ever wonder what's being listened for, we can do that with these next methods. So we can see what events have listeners by calling event names. This will return an array of the event names. We can also specify the event name and get a list of the listeners. In our example here, we will list out the open listeners and then call the second listener in that array. Then finally, we will change the max listeners. By default, the amount of max listeners is 10. This means every event can have up to 10 listeners. To change it, we will call set listeners. So let's run that and see how this works. So again, we need to move our comment down to here. So here's event names. This will give us everything that's being listened for. And in here, we are just specifically asking for open listeners. And then we are saying get that array of listeners and call the second one. Remember, arrays are 0 indexed, so 0 is 1, 1 is 2. And in here, we're going to get max listeners, which should return 10. We're going to set it to 20, and then make sure that it got set. So let's run this and see how that works. And I forgot to save. So let's run this and see how it works. Okay. Again, these are going to run in front of our asynchronous stuff because they are synchronous inline. So here's an array of all the events that have listeners. Then we said give us all the listeners for open. And as you can see, it's 2 functions, which makes sense. We set 2 functions on it. Then we said call the second function from that array, which files open second listener. That makes sense that that was the one that ran. Then we said get the max listeners, set it to 20, and then get it again. So max listeners 10, we set it to 20, it returned 20. Okay, so this is a way that you can kind of manage and see what listeners have actually been set up on this object. Now the final thing that we will look at is removing listeners. Now we should always do this before we get rid of the event emitter. One of the biggest culprits of memory leaks is event listeners. Removing listeners is a good way to avoid these kinds of memory leaks. Now, this is also the reason that there's a max listener limit. By limiting it to 10, you only have that much space to create memory leaks in it. So, for example, you couldn't add 100,000 memory leaks if we had a bad for loop that kept adding a memory listener. Or if it kept adding an event listener. Okay, so to test this, what we will do is we'll set some timeouts to call a function to remove the listeners and then emit the events again. So let's take a look at that and then run it. And finally, we'll move this all the way down to the bottom. Okay, so asynchronous calls will happen after this, so our set timeouts. So we're going to remove listener. Now, if you want to remove a specific listener, you do need to keep a reference to it, which is one of the reasons why I created this as a variable. So we can save this function in a variable, and then we can reference it here. So if you've saved that function, you can get rid of that listener and just that listener. So we remove it, we'll say that we removed the listener, and then we will emit the open event. And that will happen in a second. And then we remove all listeners off of open, and then we'll say that we've removed them, and then emit the event again. And that'll happen a second after that, or 2 seconds. So we should only see one listener fire after this, because we're removing one of 2, and then nothing should fire after this. So let's go ahead and run that. Again, I need to save it first, and then run it. So there we go. All right. Again, asynchronous, these are past that first event loop, remove one listener, and then we fire the open. And then we only get the second because remember we removed the first listener. So when there were 2 listeners, 2 fired, we removed one fired. Then we fired the event again after removing all the listeners and nothing fired. So this is a way that you can remove listeners that you no longer want to fire anymore. So in this video, we've seen how to add listeners, inspect what listeners are available, and then remove those listeners as needed. Now in the next video, we will go ahead and create our own object that will emit events. We will create our own event emitter. Welcome to creating our own event emitter. In the last video, we learned all about adding and removing listeners to an object that emits events. In this video, we're going to learn about the opposite side of that transaction, emitting events. We will create a class that will emit events. We will see what that looks like from the inside. Let's get started. First, open the file ouremitter.js in this sections directory. Now, first thing we need to do is require the core module events, which will give us a base event emitter. We then extend that object. Now, technically, at this point, we have an event emitter. And that means everything we've learned in the last video will now work for this object. This means on, once, remove, emit, and more are all available at this point once we extend event emitter. So going on to the constructor method, now this is fired when the class is initialized with new. First thing we do is call the super method, and now we can add to the object. So what we are doing here is creating a set interval to fire every second. And it will emit out the current time as a timestamp. So as you can see, if the interval ID is ever null, we will say, hey, there's an error, there's no timeout, this isn't running. And then we're going to emit the second with the date now, which is the timestamp. And this runs every second. Now, after 5 seconds, we will kick off an error. Now this is completely arbitrary, but it's a good way to demonstrate what happens when an error fires. So after 5 seconds, we will do that. Then finally, after 12, we will emit an end event and then get rid of our set interval. So it'll stop ticking every second. So this is a blueprint for emitting events. Usually there's a process that will do something and we are not quite sure when it will end. So a good way to do this is emit an event when certain actions happen. Maybe when it starts, then every so often as data comes in, and then finally when you're done, you say, We're done. Now in the next section, we'll talk about streams, which streams are a perfect example of event emitters. Now let's look at index.js to actually look at this. So of course we need to require it to use it. Then we have to create a new instance of it. And then we have this log function, which just takes something in and logs it out. Now, we listen on each event. So on second and an error, we will just log out what we're given. So let's go ahead and run this. Node.index.js. So what we should see is every second a timestamp, then after 5 seconds an error, and then after 12 an end. So let's see if that's what this does. So those are firing every second. We just got our arbitrary error. After a few more, this should end. And we are done. So this worked exactly how we expected it to. We emitted events inside of the object, and then when we used it, we said, hey, listen for them, and then log out whatever comes through. So let's test out what happens if we don't listen for the error event. So let's comment that out, save it, and then kick this off again. Starts how we expect, and then it crashes. So it said unhandled error event. Now the error event and the listener are special. If we do not have a listener and the error event is emitted, Node.js will exit and print out a stack trace. Now this is the only event that is like this. And we can see this by putting error back in and then commenting out second. So now we will not see it every second, but Node.js should still work. So we've already missed 2 or 3 second events. There's the error, but Node.js did not crash. And there's the end event. So we can skip other events, but you can never skip error if it's defined and an error is thrown. That will cause Node.js to crash. So at this point, we can see that we can get a lot of functionality with very little code by using the built-in event emitter. Now in summary for this section, we have learned what event emitters are, and more importantly, why they are useful in Node.js. Events really are just asynchronous across an indefinite amount of time and an indefinite amount of returns. We then learned about how to manage listening for this. Finally, we created our own event emitter that will do everything that we discussed earlier. Now in the next section, we will get to see a great implementation of event emitters and events in streams. Welcome to the section Node.js Streams that is part of the series, The Complete Guide to Node.js. In this section, we will look at the basics of streams. Starting off, we will learn what streams are and why they are useful. Then we'll see how to use streams by looking at readable and writable streams. Finally, we will learn a useful method of piping a stream into another. This is the first video of the section named Everything is a Stream. This is named just like the last section's video. It is not literally true, but highlights the fact that you will most likely need to use a stream in many Node.js projects. In this video, we're going to cover what a stream is, why streams are important, and commonly used streams in Node.js. First, we'll cover what streams are. A stream is a stream of data. I feel an example would explain this best. In the previous section, we were opening a file and reading the contents. This was not a large undertaking, as the files were very small, around 20 characters or so. It makes sense to open and completely read in the file and return that as data. Assuming the text has no special characters, each letter should take a byte. This means that it is only 20 bytes. Conceptually, this makes sense that we can easily pass this file in as a whole around anywhere we want. Now think about if the file is 2 gigabytes in size. That is 2 billion bytes. It would seem wasteful to have it to first load all the data up. One more time. It would seem wasteful to have to first load up all the data before we return to anything. So something needs to be done so the file can be loaded. This is where streams come in. Instead of loading the entire file, chunks can be loaded. While this is not a perfect representation, we can use a 20 byte size from earlier. So to read the 2 gigabyte file, we can just split up the file 100,000 times and we'll have the entire file 20 bytes at a time. This is what a stream is. Now, how would Node.js let our code know that it has a chunk ready? Well, this is where what we learned last section can be applied. It uses events. Streams are event emitters in Node.js. Every time a chunk of data is ready, the stream will emit a data event with the data. We technically have done this already, but all the files we opened last section were very small, so there was only ever one data event. Now, streams fit perfectly into the Node.js architecture. Node.js is non-blocking, so we do not tie up the CPU while loading a large file. Streams use events, which are just callbacks that can be fired multiple times. So breaking it down, a stream is just a series of asynchronous callbacks that execute with different data each time as it moves through the file. So let's go ahead and create an example object to kind of demonstrate this. Now, we are not going to send a multi-gigabyte file with the code, but if you do have a multi-gigabyte file, you can go ahead and test this out yourself by trying to read that in and looking at all the data events that fire. Now for this video, we are going to use fakereader.js, which is under section 2.1. So this is just a class that's going to emit an event every 250 milliseconds with different data. Looking at this at a very high level, this essentially is a stream. Now we can see the class here. We require events, we use event emitter. Again, this is stuff that we did in the last section. And then every 250 milliseconds, we pop out some more data. So let's go ahead and run this. We do this by using index.js. We do this by requiring it, then we create a new one, and then we just say on data, log the data that comes in. So we will run this, node index, and there we go. So again, this was a very loose example of what a stream could be, but this is kind of what streams do. It reads in a certain size amount of data and then lets you respond to it by using the data event. So now looking at what are streams in Node.js, as we just talked about, pretty much all file system reads and writes can be streams. Some cryptography and compression functions also are streams. And finally, anything that uses a network will be a stream. This includes raw sockets created using the net module and also higher level modules like HTTP and HTTPS. Really, when we break it down, almost any time we are reading or writing data in Node.js, it will be in a stream. Having the readable and writable streams allows us to just worry about getting and writing data and not where it is going or where it is coming from. In this video, we covered what a stream is. Then we discussed how the idea of a stream fits perfectly in Node.js, as it is non-blocking and asynchronous. Finally, we learned about some modules which are streams. In the next video, we will use some actual streams in code to see how we can read data using a stream. Welcome to Readable Streams, which is part of the course The Complete Guide to Node.js. In the previous video, we discussed what exactly streams are and why they fit in the Node.js model so well. In this video, we're going to cover what readable streams are, how to create them, and then how to use them. First thing to cover is that readable streams are just streams that can be read. In Node.js, streams can be one of two types, readable or writable. Readable streams allows us to get data out of whatever the source is. This is great as it abstracts away the concern of where the data is and lets us just focus on getting the data. Now let's create our own readable stream. So open up section 2.2 and look for the file ourreader.js. Now, first of all, this file requires the readable object from the stream module. What's great about using this object is the class has everything ready except for the actual reading part. This means that all the methods and events are ready. Here we're going to use a generator. Now, a generator allows us to return multiple times from a function with yield. So when it's executed, it executes up to a yield, returns that, and then when you call it again, it'll call up to the next yield, and so on until it runs out of yields, and then it will return with an undefined. Now, this is perfect for simulating a file that has 4 lines and then it's done reading. So we're going to use that as our source of data. So we extend the readable object with just a constructor and the underscore read. The constructor, we just take it and set up our generator. The underscore read method is just going to get the next value out of the generator and keep doing that until there are no more. And then we're going to call this push, which tells this readable object, again, this is all wired up automatically for us, to output this to the object that's trying to read from this stream. So let's see how to use it. Let's open up index.js. So here we require that object so we can use it, and we're going to use it 2 different ways. One way is with an encoding and another without the encoding. So first we'll do the encoding. And then we set up a data event, and we're just going to log the data right to the console. Before we do that though, we're going to pause it, because remember, this is an asynchronous call. It's going to say, hey, when that event fires, log it to the console. And usually by registering this event, we'll start the data to flow. But here we're saying pause. And then we're going to wait 500 milliseconds and then resume it. So this demonstrates the fact that we can pause a stream at certain times and then resume it later. So let's go ahead and see encoding work now. So there's our wait, 500 milliseconds, and then it returned all the lines. So this worked exactly how we expected. If this was a file with 4 lines, we would have read it out exactly like this. So now, let's try it without the encoding. Uncomment that, comment that, save it, and then rerun this. So now we get buffers instead of actual text. So a buffer is actually just an array of raw bytes. Now we can decode this and turn it back into text. In fact, if you notice, the last 3 lines all start with here is the, and you can see that all of these lines right here are exactly the same. So that is actually the text. Here is the on these last 3. So a question comes up, why would we want to use a buffer? Well, a buffer is great if you're not dealing with text. For example, you could be streaming a binary file. Then you would just want the raw bytes to deal with. But if you do have text, then you probably want to put an encoding on it so that you could just read the text. So depending on what you're doing, each one of these will be useful at different times. So let's look at one more example. We'll do file reader. Now this is something we have done. We've created a read stream before, but we're going to read it in a different way. So here you notice we're not actually listening for the data event, we're listening for the readable. So this will fire when the stream is ready to be read from. So inside of that then, we're going to read from the reader. And in this one means read 1 byte out of the file, and then we're going to log that. So let's see what happens when we read this 1 byte at a time. So we will call node file reader. As you can see, it output every single letter on its own line because we asked to read it 1 byte at a time. So this is a great way to have a little bit more control over how we want to read out of the stream. When you call a data event, you're going to get a chunk of data and then you'll deal with it. Here we're saying, once it's readable, give me 1 byte at a time. And of course you can put whatever size chunk you want right here. Now I would like to note that it is highly recommended to use a data event over manual reading. So unless you have a specific circumstance where you need more control over reading, usually just calling a data event is enough. Eventually you will get all the data out of the file, out of the network source, out of wherever you're reading from, and you can do something with it. In this video, we have covered what a readable stream is, It's just a stream that you can call read on. We implemented our own readable stream, and then we used a stream to automatically read and then one to manually read. So we kind of covered all the different great ways that you can use it. And we even saw how you can pause streams and resume them. In the next video, we'll look at the other stream type, writable streams. Welcome to Writable Streams, part of the course, The Complete Guide to Node.js. In the previous video, we looked at readable streams, what they are, how to create them, and how to use them. In this video, we're going to look at the opposite side of streams, writable streams. This will be very similar to the last video in that we will see what they are, create one, and then use it. Now, writable streams, this is the opposite of readable streams. And we can kind of use the same examples that we had before, but in the other direction. So, let's say that we need to write a 2 GB file or send it across the network. Same problem we had with readable, we cannot just send the entire file as a 2 GB chunk. We will have to chop it up into smaller chunks and then write that. That is what a writable stream is. So let's create a writable stream right now. Go to section 2.3 and find the file rwriter.js. So open this up. Now, a lot like the readable, this is going to be our implementation of writable. We're going to use the writable object that comes from the stream module, and then we will extend it. And just like the readable stream, we only really have to overwrite one method, and that's the underscore write. So here we're going to take an array, and then everything that's written to us through the writable object, through the writable stream, we will put into this array. And then we're adding one more function, getSource, so that we can actually see what's in that array. So let's go ahead and use it right now. In index.js, we use it. So we require it, we initialize a new object, and then we write to it. So we write one line, then another line, and then this is where our getSource comes in. We can now see what's in the array. So let's run this. So it's going to be node and then index.js. So we can see this return the buffers. Now that makes sense because we talked about before that really when you break down streams, everything's pretty much passed as just a buffer of bytes. So that's our text as bytes. Now, we can add some options when we create the writable object. Again, these are all wired up in that core module for us already. So we are going to say, do not decode the strings. So leave them in the encoding they are, which with the string, it'll get returned just as a string instead of a buffer of bytes. So let's run that. And there we go. So we get the actual strings back instead of buffers. Again, just like the readable, it is actually going to depend on what you're doing. If you're just dealing with text, leaving them as the encoding is just fine. But if you're dealing with binary files, leaving them a buffer of bytes is the way to go. Now, instead of using one that we create, let's use a built-in writable stream. This is in filewriter.js. This is going to use the file system module, fs, so we create that, and then we're going to create a write stream, and we're going to name it test.txt. Now here, there are some options that we can pass in, but by default, the file will be created if it does not exist and overwritten if it does. So there's one now. I'm going to go ahead and delete that. Okay, so what we're going to do is we're going to call two calls to write, and then we're going to call end. Now in our previous example, we did not call end because we were just writing to an array. But when you do have a writable stream that does deal with an actual resource, like say a file, you want to call end because then that tells the object that, hey, we're done with it. You can flush all your buffers, you can write everything, and you can release any holds that you have on the file. Now a file is a perfect example of something that you do want to release that hold because otherwise that could stay there and that could cause problems elsewhere. Now that we've written it, we're going to go ahead and try and see what's in that file. So immediately we're going to call read file. So this comes in, and we're calling this before because this is before the finish event. So most likely this will either be null or it won't have the whole file. The reason for this is, as we have covered before, is that Node.js is asynchronous. So those writes are not happening immediately. So they take some time to actually go to the file. So this will either be null or it'll just have a partial of the file. Now, there is an event that says, hey, I'm done writing, and that is the finish event. So if we wait for this event, we know that the full data will be there. So let's go ahead and kick this off and see what happens. So this is node FileWriter.js. So there we go. We have the before, and it's actually half of the file. And then after it's done, it's the full file. So this is the full examples that we're going to use. Now, writable streams are actually a little bit easier because you pretty much just write and then you let the source figure out what it needs to do, whether it's a file, to write it to a file, or say like a network stream to actually stream that data to where it's going. Whereas readable, there's a couple things that you can do to change how it's read. So in this video, we've learned what a writable stream is, how it's opposite of a readable stream. Then we created a custom writable stream, and we implemented that, and then we used the file system writable stream to show how an actual Node.js writable stream works. In the next video, we'll look at network streams. And because we already know about readable and writable streams, this will actually be really easy. Welcome to Network Streams, part of the course The Complete Guide to Node.js. In the previous video, we learned about writable streams. So at this point, we've learned about both readable and writable streams. Now in this video, we're going to take a look at network streams. So just like the other videos that we just did with streams, we will discuss what a network stream is, and then we will use it. First, let's talk about network streams. Network streams are streams of data, just like all the other streams. One of the interesting things about them are they are duplex. So this means that they are both readable and writable. Now I feel that network streams are also the quintessential stream. When you think about what a stream is, which is data that is passed in chunks, then a network connection is a perfect example of that. A network connection is just a bunch of packets of data that arrive at different times and is streamed from one server to another. So let's write some code. So open up the file server.js under section 2.4. So in this script, we are going to build a server that then will connect to a client and they will send data on both sides back and forth. So let's look at what we have here. So first thing we do is use the net module. So we need to require it. Then we create a server. By doing this, this gives us an object that we can start listening for connections on. And then that's what we do. So on connection, we can run a function that gives us a socket. Now, a socket is the actual connection from the client to the server. And this socket object is the object that is both a writable and a readable stream, as you can see. So we take the socket and we write to the client saying, hey, you connected to the server. Then we will read the data from the client and then output it by saying, hey, this is what we received as the server. And then we will write back at the end of that saying, we handled that data. And finally, we start the server by saying, listen on port 5000 on the localhost IP address. So this is the server side here. As you can see, we have writes and we have reads. So it's a duplex stream. Now we need to create the client to connect to this. Now we're just going to do this in the same file. So we create a socket. Again, that is a connection from one computer to another. So this socket is from the server to the client, and then this one's going to be from the client to the server. So we connect on the same IP address and port, and in here we say when we connect, write to the server saying client sending to server. So there we see it's a writable stream. And then we use it as a readable by saying on the data event, again that's a readable stream event, we will output what was sent to us from the server. And then eventually we will close the client connection and then we will stop the server after 1 second. Now we need to do this because if you have a server that's listening, Node will actually stay up because it's in the event loop listening. Okay, so let's go ahead and run this and look to see how we pass data back and forth from a readable to a writable stream, and then vice versa. So it's node server.js. We run it, and there it goes, and then it closed. So if we look at this, we see that the client connected, and then it wrote something. Client sending to server. So the server listening then output that. So we have server data, client sending to server. So there's the write, and then here's where it listened. And then it wrote back, data handled by server. And then also on the connection, it wrote connected to server. But remember, these are asynchronous events. So the first one that was output was by the server. And then we have the client outputting, because we have here, on any data sent back, we have client data, and then we're going to output it. So we have connected to server, and we have data handled by server. Now, these aren't two separate, because remember, usually behind the scenes in a stream, there's a buffer. So we wrote originally connected to server, and we wrote data handled by server. But that's not a lot of data. So it just stayed there until eventually said, oh, the connection's closing, let's send that data. Okay, so there's not a lot here to cover because we've already covered readable and writable streams. But I thought it would be really important to show A, network streams, and B, duplex, and an actual example of this happening. Now this is a great way that you can listen for and also connect and send data and receive data across the network. In this video, we created a network stream and we saw how we can send data across a duplex connection. Now in the next video, we'll learn about the final feature of streams, which is piping. Piping allows us to easily take data from one place and then stream it to another place. Welcome to Piping Streams. This is the final video of the section on streams. In the previous video, we used network streams. Network streams are interesting because they are both readable and writable. Then we built a small client-server script and then sent data back and forth. In this video, we're going to discuss piping. This will continue with our current mode of operation of introducing the concept and then building something with the concept. So let's go ahead and get started. So take as an example a readable stream and say we want to connect it to a writable stream. For example, copy the contents of one large file to another. Using what we've learned so far, we would do the following. Create a read stream and then create a write stream. Then we would create a listener for the data event from the read stream. Then inside the handler for that, we would call the write method of the write stream with the data from the data event. Finally, on the end event of the read stream, we would call the end on the write stream. Now doing this is called piping. We are piping all the data from the output of a stream into the input of another stream. Any readable stream can be piped to the input of a writable stream. Now, the great part of this is that Node.js makes this even easier than what we just detailed. All readable streams have a method named pipe. So let's go ahead and use it. So first we can see piping in action from most Unix shells. I'm using Mac OS X, which has a bash shell. I can run a command, then pipe it into another command. I will use cat and file test.txt. If we run that, we see that output the contents of the file. Then we will pipe it using the pipe character into WC, which is word count. Now this will output new lines, words, and bytes. So if we run this, we see that it takes that output from cat and uses that as the input. So we see it said it had 4 lines, it had 17 words, and 79 bytes. So we can see how this can be really beneficial. We can take the output of something and then easily pipe it into the input of another. So of course, let's do this in Node. And we're going to do this with the pipe.js. Here we will set this up, ready to be executed. So we can see this with the file pipe.js. So in Unix there is the idea of standard in and standard out, which is std in and std out. These are the input and output of the console respectively. Now this is greatly simplified, but this is not a course on Unix. So I just want to let you know what that is, and we're going to use it here, but we don't need to know it past that one is standard in and one is standard out. So Node.js allows us to reference these using the process module. So let's take a script and do what we just did there. Take the standard in and pipe it into standard out. So here's standard in. This is readable, so we can say data, and standard out is writable. And we'll write the data that comes in back out. So we'll use the command echo.test. We see it just outputs test. And then we're going to take it and we're going to pipe it into node.pipe.js. So we run that, and even though it did the same exact thing, we actually did it here. So again, this is like we talked about earlier, where you take the data and then inside of that you write it. But all readable streams have this pipe. So this says take the output of standard in and put it to the input of standard out. So if we save this, this should actually output it twice. It should do it here and then also with the pipe. So let's rerun this. And there we go. So we can see we turned 3 lines of code into 1. And actually, when you think about it, it's even easier to think about because you're saying take all the data from here and just pipe it into the other. Now, this really isn't that useful because this is actually what the Unix shell is doing anyways. So let's go ahead and change this up. And then we're going to say take the output of this and put it to this file write.txt. Now, I have a write.txt, and I'm going to go ahead and delete this. So we should see it actually create the file and output what we put in here. So we're going to run it again. And we see write.txt was created. And we crack it open, and we see that it has tests, which is what we expected because that's what we wrote. So here we can start to see that you can pipe any readable to any writable. It doesn't have to be standard in to standard out. You have a write stream, you can pipe any readable stream into it. So let's even take that one step further. Now, we used network streams in the last video, and we're going to use them here. So again, we need to use a net module. We're going to create a socket, which remember, that's a connection from one computer to another. And then we're going to say we're going to go to Google, and we're going to do port 80, which is a standard web port. And then we're going to pipe the output of that to standard out, and then we're also going to create a file called google.txt. And to kick this all off, we're going to write to that socket. Remember, write is readable and writable. This request, which this is a get HTTP request. Again, we're not going to cover this in depth, but just know that this tells the Google server to return a response. Now, I'm going to go ahead and delete this file again so that it'll be created new. Make sure this is saved, and then we are going to kick this off. Now, it'll do all the outputting, writing the files, but we want to make sure and see that it actually calls Google. So we'll call this, and we see that a lot of stuff was returned. So this is actually all the JavaScript on the Google page. It output the Google page to standard out because that's what we said. And again, as we see here, you can actually pipe a readable stream to multiple output streams. And if we open google.txt, we see here's the HTTP headers that were returned from Google, and then here's the actual HTTP page. So we can see that this worked. And again, once you get your head around piping stuff, we can take any readable stream and pipe it to any writable stream. And that's it. Now, there's one more thing that we want to cover before we go on, and that's going to be transforms. So transforms are streams then that transform the data in between an input and an output. So to see this working, let's go ahead and look at transform.js. I'm going to clear this. So here's a simple transform. Now, we use the stream module again, and inside of it, it actually has So we're going to use the stream module again, and inside of it, we see that it actually has a transform object. And much like the readable and writable, all we need to do is implement one method, which is the underscore transform. So here, we're going to take the chunk that came in, turn it to a string, and then turn it to uppercase. That's all it does. Take any text, return it as uppercase. So let's look at upper.js, which actually uses this. Now we'll comment this one out because we'll look at this in a second. So what we're going to do is take standard in, pipe it into that transform, upper transform, and then pipe the output of that to standard out. So let's go ahead and see this working. So we will just echo test, and then we will pipe it into node upper.js. So we see that it took that test and turned it to uppercase. We can use it with our first cat method that we were using before. Run node upper.js, and we see that it turned the entire file into uppercase. So this is working great. Now, like a lot of examples, this is very arbitrary. So let's look at a real-world example. Let's say we want to gzip a file. Now, gzip is a way to compress a file. And Node.js allows us to do it with the zlib module. So in the zlib module, we have create gzip. So this will compress the data from standard in and then pipe it to standard out. Now again, if you want to do this for real, you'd most likely save this to a file. But here we're just going to output it. So this is a great example of a real-world transform that you most likely could use in your code. So let's go ahead and run the same example that we just did, but this time we have the gzip in. So we run it. Here we have our transform to uppercase, and then here we have it compressed using gzip. So again, it's hard to tell if it's actually gzipped because it's in a form we cannot read, but we can see that that text was transformed. So that is it for transforms. Now in this video, we learned what piping is, which is just sending data from the output of a read stream into the write stream. Then we piped a bunch of streams. We did from standard in, we did from a network connection, and we wrote to standard out, we wrote to a file. So we can see that any readable can be piped to any writable. Finally, we then learned how we can then insert another step into the pipe by using transform to do something. So overall in this section then, we've learned all about streams. First, we saw how streams are just an asynchronous way of looking at a file, or really any other data, and why they fit so well into Node.js. Then we learned how to use a readable stream to get data, and then we used a writable stream to write data. Finally, we learned how network streams do both, and then in this video, we piped streams together and ran a transform. In the next section, we'll start to actually learn how to build useful applications using the Node.js HTTP server. Welcome to the section Node.js HTTP server. In this section, we will see what an HTTP server is and then learn how to make one using Node.js. Then we'll see how to make HTTP client requests. After that, we'll learn how to handle requests and responses to the server. So in this first video of this section, we're going to look at the HTTP module. We're going to do this by learning what an HTTP server is, then we'll build our own, and then finally, we'll see how to use the Node.js module for HTTP. So the first thing we're going to discuss is what an HTTP server is. First of all, I think I can safely say that everyone has interacted with an HTTP server before. At the most basic breakdown is that an HTTP server serves web pages. It does this by following the protocol HTTP. Now, at a high level, the protocol allows for different kinds of requests that then the server makes responses to. Now in this video, we will create a server that responds to a GET request with a 200 status code response. Now HTTP servers are very important today as many applications are built to run over HTTP. We have most likely used some of these. They range from simple websites to looking at email to watching videos to banking to essentially almost anything. The course that follows this course will go into building HTTP applications. Now in this course we will just be covering the basics of an HTTP server here. So let's see how to write that. An HTTP server runs over the network, so that's the module we pull in, the net module. Then we create a network server. From there we connect to the connection event. This will give us a socket, which, as we've learned before in our stream section, that a socket is both a readable and a writable stream. And we're going to do both of that here. So the first thing we do is read from it and log out the actual request from the browser. Now here we are making no decisions about what to do. No matter what the request is, we're always going to use the same response. And that's what we do here by writing out a response. So this is the protocol in action. So we're saying we're HTTP 1.0 and a 200 response. We're saying we're HTML, and then here's the actual HTML. Now this is very, very simple. It's just going to say our web server. Finally, we tell it to listen on this IP address on this port. So let's go ahead and run this and make an HTTP request to it and see what happens. So in the console, type node and then run custom HTTPS. So at this point we see that node didn't die, so we know that the HTTP server is listening. So here, I'll go ahead and make the request. We see that it responded, our web server. Okay, let's see what the request is on the console. As we can see here, this is HTTP. It said a GET request for the URL, the root, and it made an HTTP 1.1. And then here's some other information, but this is the actual request from the browser. And as we've seen, we return a response that the browser then rendered. Now this is a little bit of code. We can actually do this a little bit easier. So this is going to use Node.js's HTTP module. So when building this, it's going to work very similarly to the net module. And this is because HTTP is a network server. Now instead of net, we're going to use HTTP server. Instead of net, we're going to use HTTP as a module. Then we'll create a server here. Now instead of listening to the connection, we'll listen to the request. Now in this returns, instead of getting a socket, we're actually going to get a request and a response. Now in the next couple videos, we will spend time on these objects. But for now, just know that response we can write to and request we can look at the actual request. So here we're going to log out the URL for the request, and then we're going to return a very similar HTTP. We're going to return a very similar HTML page. This time we're going to say Node's web server, and then we listen, just like before. So let's go ahead and run this and see how this runs. Now as you can see, this is actually less code than we used before, but we actually even have more things because the request is actually parsed instead of just being a stream of data. Let's run this. So this is node HTTP.js. We run it, we see it's working. Let's make a request. We have the browser up again. I'll press refresh. It's the same IP address and port, and we see we have Node's web server. Okay, let's look at the console. And here we go. So we can see that it was a request for the root. Now instead of getting just a stream of text, we actually now have an object that kind of breaks this down. So we can see that it is the same here, a request for the root. And return the same HTML in less code. So that is it for this video, as we will cover other pieces of this more in depth in later videos. So in this video, we've discussed that HTTP is a very attractive way of creating and delivering applications. We have all used HTTP to do many things. We then built the simplest web server that you can build on Node.js. There were not many features, but it did serve a web page. We then built a similar server, but we used the Node.js module HTTP and did this with less code. Now, in the next video, we will cover how to make client requests, just like using a browser, in Node.js using the module HTTP. Welcome to Making Client Requests. This is part of the video series, The Complete Guide to Node.js. In the last video, we discussed how we can use Node.js to run as a web application server. In this video, we're going to take a look at making HTTP requests in Node.js. With HTTP servers running almost all the applications on the internet, we will find ourselves making requests often. We will cover how to do this easily. As I've just stated, web servers do many things today. They are not just static document portals like they were 30 years ago. All types of applications are hosted and accessed through web servers. A great example of this is an architecture known as REST. This is a way to store data on a web server and allow someone to interact with the data. As an example, it could have an endpoint of users that would list all the users. Then we could go to user/1 and see the first user. It all runs on HTTP. Knowing how REST works is not required for this video, but just know that it is a popular way to make data accessible and that it runs completely on HTTP. This means that we'll find ourselves needing to make a request of a web server. How do we do that? First, we'll look at making a manual request. We've actually done this in an earlier video, but we will look at it again. Let's go ahead and open the file manual_request.js. We're going to require the net module because HTTP, of course, runs over the network. We're going to create a socket. We're going to go to google.com and we're going to use port 80, which is the HTTP port. Then we're going to pipe that output straight to standard out. And then here is our HTTP request. We're going to make a GET request for the root folder. We're going to make a GET request for the root. And then we're going to call end. So let's go ahead and see what happens when we call this. So we will do node manual request.js. So we execute this, and there we go. It went out to Google and returned the HTML. If we had a browser and threw this in, we would see the Google homepage. So let's actually look at this using a Node.js module, which is a HTTP module. So open client request.js. So here we're going to require the HTTP module, and then instead of writing out the request, we're going to create an object. So here we're going to say the host name is Google and the method is get. Then we call the request method off of HTTP, passing in the options. What's returned then is a readable stream that is the response from the web server. Because it's readable, we're going to read it out and log it to the console. And then we call end. Let's run this and see what happens here. Client request.js, and there we go. It returned the same page that we just looked at. So this is the same request. Now the value over this is when you start getting into complex HTTP requests, this options object is going to be much easier than hand coding your own HTTP request. Now one thing I want to note is that you must call end on the request. If you do not, it will just hang. In fact, we'll go ahead and do that now by commenting it out, save it, and then rerun this. As you can see, it's just staying here. As you can see, it's just paused here. Nothing's getting returned. I'm going to go ahead and kill this, comment this back out. So that is definitely something that you want to remember. If you're trying to make a request and it seems like it just halts and nothing gets returned, remember to check if you've called end on the request. Okay, so let's look at one more piece of code. This is going to be API request.js. Now this is going to be kind of a better example of what you're actually going to do when making HTTP calls. Most likely, we will not be loading HTML web pages in Node.js. Most likely, we will be using it to make an API call to get data from some server. So let's look at this one. Again, we use HTTP module. Here are our options. This is an example web server that will just return arbitrary data from an API. We're going to say give us all the users, and we're going to call a GET request. Now, this is in the form of, this is the architecture of REST, in that we have a resource, and then depending on the method, determines what we're going to do. Again, you don't have to completely understand REST, but just know that this is a popular way of being able to get data out of web servers. And then we're just going to call it much like we did before. We pass it in the options, we just output what's returned, and then we're going to end the request. So let's go ahead and call this. So there we go. This returns some data for us that we can then use directly in Node.js to do something with. Now quite a few services will have APIs that use REST just like this, as it has pretty much become an industry standard. So using the HTTP module and the request method, we should easily be able to consume an API and get data into Node.js. So in summary, we have seen that we can use HTTP module to make HTTP client requests to different endpoints and different servers very easily without having to actually write out a full HTTP request. Now in the next video, we'll see how to handle a request when we are running our own web server. Welcome to Handling Requests. Welcome to Handling Requests, which is part of the Complete Guide to Node.js. In the last video, we learned how to make a client request to a web server. In this video, we're going to take a look at how the request object in the HTTP module works. We will do this by looking at the request object, then create a small application that will use the object to handle requests. So the first thing we need to do is create an HTTP server and see what is in the request object. So let's open up example.js. So in here, we have the HTTP module, we create a server, and then we are just going to log out the request object and then just take a look at it. So inside of section 3.3, we will say node example.js and then run this. So I'm going to make a request from my browser and then we'll see the request object. So there we go. This is the object here. As you can see, there are quite a few things in it. Now one thing to remember is that here, for example, this is socket, so all of these properties here are properties off of socket and not directly off of the request object. If we come up to the top of this object, we can see that these are the actual properties from it. So this is much more useful than just getting a string of text, which is technically all an HTTP request is. So let's look at some of these properties. So we will comment out that, and then we will look at the headers, the raw headers, and the HTTP version. So I will save this file, stop node, and then start it again. I'll make another request, and here are the headers. So if we come up here, headers is an object, which for each property is a header. So we have host, and it tells you the host that a request had. We can see the user agent that was used. We can see some accept coding, accept language. So everything the browser used to request this page is here for the headers. Now the raw headers are essentially the key values of the header, just broken up into just an array of strings. And finally, we have the HTTP version here. Now for the most part, we won't need to do much with these properties of the request. There are definitely use cases for using them, but we won't cover them here. We will now look at the most useful properties of the request, which are the method and the URL. So we will save this, stop it, and then restart it. I will remake the request, and we see that this was a GET request to the test URL. Now with these two pieces of information, if we have a web application, that's enough to make a decision of what to do. With this method and this URL, we should do X. So how do we do that? Well, we're going to build that right now. So this is going to be our first Node.js real application that we've built in this section. We are going to build a router. This router will take a method and a URL and then execute a function with the request and the response object. Now this is pretty much the most basic thing that an HTTP web application can do. So let's open up routes.js and take a look at this. So the first thing we do is create an array that will hold all the routes. Then we create a function, register route, that will allow us to register that route by giving it a method, a URL, and then the function we want to run. Now these next two are matching. So either the route and method are undefined, or it'll actually match the route and method. This next function just puts those two together so that it will uniquely identify a specific method and route. And finally, we have to define something to handle the request. Remember, when we create an HTTP server, that it has a request event that passes in a request and response. So we will take those, we will filter down our array of routes that only map to the ones that will map to the ones that match, and that's going to match based on the method and URL, and then we will execute each one of them in order. Now this sum just means that when any of them return true, it'll stop executing. And finally, we need to export these methods so that they can be used in another file. So we have this register route and the handle request, which we're going to export. So let's actually see it in action. We'll go to server.js. So here we require the HTTP module. Then we require our routes file that we just created. The next part that we're going to look at are the actual responses/routing functions that we will use. So we will create a logging function which will take the request and then echo out the method and URL for each request. And we know this will work because we return false, meaning that it will continue the chain of functions to run. Then we define an index function, again takes the request and response, and then it will return an HTML page and return true. So this return true will stop the chain. Finally, we will put a default route, which will just end the response and then return true. So we'll put this at the end, so if anything doesn't match, this will match and then say the request is done. Now here's where we register the route. Remember, we're going to pass it in a method and a URL. Both of these are undefined, meaning it'll run for every request. And then we say run log. Then we're going to say on the get request in the root URL, run index. And then for everything else, because this is the last one, run default route. So we create our server, and then on each request event, we're going to say handle request. And again, remember this request event passes in the request and response objects, which this function will then pass them out to each one of these functions, depending on if they match this route. And then we tell it to listen. So let's go ahead and run this. We'll stop this and run node server.js. So it is now listening. I will come over and kick off a web page. And as you can see, I made a GET request to the root URL, and it logged that response. And if we look at our router correctly, GET request to the root URL should return the index function. So let's take a look at the web page. So here's the output of that request. As you can see, that is the HTML that we expected to see. And because this returned true, it did not run anything else after it. So let's make a request to a different URL, the one that we tried before. Let's try test. So I made the request. As you can see, it logged out the console. It made a GET request to the test URL. Now this did not match the index, and we did not get a page. We essentially got an empty page, which would mean that the default route executed. So as we can see, we've actually built a little application that sat on top of the core module of HTTP that takes the request, determines what to do with it based on the method and the URL off the request object, and executed a function. So this is a great example of taking a core module in Node.js and then building on top of them to create something powerful. So I would like to note, though, that the application we built, the router, is not fully functional. There are definitely some problems. For example, it doesn't handle errors, and any parameters in the URL will mess up the routing. But it does highlight how quickly and easily we can create something in Node.js. So if we look at routes.js, we can see it is literally 30 lines of code, yet it is still very powerful. So in this video, we looked at the request object and some of its properties. Then we created a small web application that used the request object to route to specific functions that we defined. Now in the next video, we will see how to send responses from a web application using the response object. Welcome to Sending Responses, which is part of the course The Complete Guide to Node.js. In the previous video, we looked at handling requests, so this is the other side of an HTTP transaction. In this video, we're going to take a look at what the response object is, see what is the most important parts of a response object, and then continue the development of our small web application. So the request comes from a browser, and then a web application should parse that. So we will look at the response more closely right now. So the first thing we want to do is open up example.js. This is a lot like the last video. We're going to use the HTTP module, then create a server, and then on the request, we're going to output the response, and then we're also going to take this and then set a header. So headers are returned along with the response before it. And we're going to set it, our header, to anything we want. Then we're going to go and then set the status code. So a status code essentially tells the browser how the request went on the server side. As an example, we're going to set to 404, which is kind of a well-known status code, and that just means that a page was not found. Now if we never change the status code, it will be a 200, which means everything went fine. And then as another example, there's a 500 code, which means that there was a server error. Now there are many codes, and it does matter which ones we use. But we do not have the time to cover every single one of the codes and what they mean. But I do recommend that when you get to the point when you have a web application and you need to return different status codes, is to look them up, understand which each of them mean, and then return the correct status code for the correct response. So let's go ahead and fire this up. We'll call node example.js. We'll run it. Now I will go ahead and make the response, and then we can. So I will go ahead and make the request, and then we can see the response here. As you can see, a lot like last time, there are a lot of properties off of here. Although I think the key thing that we should take from the response object is that it is a writable stream. And this makes sense, because this is a connection back to the browser from the server. So we're going to take this stream and we're going to write what we want to display on the browser. And again, the other couple methods and properties that are really useful, we've already set, which is the set header and the status code. And we're actually going to go and take a look at those right now. So let's look at these in the browser. So here's a browser. I'm going to remake the call. And then we can see the request right here. So here's the response headers that were returned. We have our header, anything we want. That's exactly what we'd expect because we set that response header. Also, we can see that the status code was 404, which we set again. Now this is the actual text that's returned from the server. We can see it's HTTP 1.1, 404 not found. We have our header, and there's a couple other headers that are automatically sent. Now, let's build on that routing application that we started in the last video. So let's open routes.js. Now, we are not going to add anything here, but I will cover this quickly. So we have a routes array, which will store all our routes. Then we have register route, which allows us to put a route in that array. This will match the URL. This will match the method of the request. This puts those together. This will handle each request, filter down our array to just the functions that match for this request, and then we apply them. Finally, we return register route and handle request back out of here. And we do this because these are really the only two public functions that we want to make available. Okay, so let's go ahead and open server.js and take a look at the functions we've defined here. So for the most part, this is very similar. We still have a log and a couple of the other functions, but we've added two here. So the first is powered by. So we take the response and then we just set a header for powered by. Now the powered by header is usually used to tell the browser what is running on the server side. And we're going to say complete guide to Node.js. We return false so that this will continue working down. The other one we've added is static. So this will take the response, it will open up the file system module, create a read stream of static.html, and then set a header of text HTML, and then pipe that file back to the response. Again, remember that the response is a writable stream. So we can take a readable stream and then say, just go over to the response. Now, one thing to remember is that we've explicitly set this static.html. One way that we could make this better is that we could actually take the request, look at the URL that they're requesting, and then see if that file exists, and then return that as a static file response. Here we just have it mapped to 1, which is fine for our example. So here are our routes. We have log, which should run on each one. Then we have powered by, which should run on each one. We have index, which will return our previously defined string that we're writing to the response. We do static HTML, which should map to static. And then we have this default route, which just catches everything else. So let's go ahead and run this and then take a look at what this looks like. So we're on node server.js. And now I will bring the browser over and we'll take a look at each one of these requests. First, we'll do the root. This returns what we expect it to. This was our page. And if we look at the request here, we can see it was a 200. So again, if you don't set the status code, you get a 200 back, which is everything is okay. And then we see we have X powered by complete guide to Node.js. So these ran how we expected them to, and they wrote to the response how we expected it. Now, let's call static.html. And here's our static page. If we look at the HTML, it was a lot like the other in that it just had a header that said static page. So if we look at the response, we can see we have the header again, X powered by complete guide to Node.js. And we also have content type here, which is text HTML. Again, that was a header that we added. So headers can be added across these functions here because we haven't ended the response, which then tells it to go ahead and send to the browser. So let's go back and see. As you can see, this worked exactly how we expected to as well. It logged everything out, all the requests. So that is it for this video where we cover sending responses. Now in this section, we have looked at the HTTP module. This is a module that makes using HTTP really easy. First, we saw how easy it is to create an HTTP server. Then we made client requests with Node.js. This is important as more and more data is being put behind an HTTP server. Finally, we created a small web application to route requests to responses. This demonstrates one of the first building blocks to creating a larger web application. Now, in the next section, we'll see one of the most popular web application frameworks in action, which is Express. Express is more robust than anything we have built so far, but many of the things we have learned will be immediately usable in Express. Welcome to the section Using Express. This is part of the course The Complete Guide to Node.js. In this section, we will install Express. In this section, we will install Express and see how the basics of it work. This includes routing, middleware, errors, debugging, and templating. Now in this, the first video, we're going to install Express. So we will discuss what Express is, and then we'll install it, and then we will use it. We should begin with what Express is. It is a web application framework. Well, what does that mean? A web application framework helps make an HTTP server function like an application. HTTP was designed to serve documents. This means that things like authentication, tracking between requests, templating, and many more things are not built into HTTP. Now, something has to do all those things that we expect a modern web application to do. This is then where a web application framework like Express comes in. It was one of the earliest and still one of the most popular frameworks. NPM lists it as one of the most depended upon packages. As of the recording of this video, Express was downloaded almost 7 million times just last month. Now today, there are definitely competitors to Express, but it is still very widely used and supported. So in addition to all of these things, it is also backed by the Node.js Foundation. Now this does not mean that Express is a core module or even a core part of Node.js. It is still developed separately. It does mean that it has clear support from the same organization that supports Node.js. So let's stop talking about Express and use it. The easiest way to install Express is using npm. The package is named Express. We can run from the command line npm install Express. Remember, if we have a package.json, we can use the --save to save this as a dependency. Or if you are following along and have the code, the package.json already has it as a dependency, Express 4.14. So we can just run npm install. Now I'm going to do that here. I already have the Node modules here, so I'm going to delete these and then run npm install. Remember, this looks into your package.json, finds everything that isn't installed, and then installs it. So there we go. Express is now installed. And again, the version we are using is 4.14.0. Just like we learned all those videos ago, npm makes dependency management a breeze. So now we can actually use Express. So we will definitely cover the workings of Express much more in depth in the next few videos. But for right now, let's just see how easy it is to get Express up and running. So we're going to open up index.js in section 1.1. Here we can see we require Express so that we can use it. Then we execute it so that we get an instance of an application that we can work with. So here we're going to do some quick routing. Now remember what we built in the last section where we had to give it the method and the URL. Here we need to do it the same way. The difference being that the method that we use, the HTTP method, is the function name. So this get means a get request. And a dash is the root. And then we have to give it a function to execute when that route is called. Now if you notice the definition of this function, this should look a lot like the definitions that we've been using. And this is because it uses the exact same request and response objects as an HTTP core module does. Now here we log them out, and if you want to look over that, you can see that these are the exact same objects. And because they're the same objects, we can use the same functions that we learned about in previous videos. So we can set a header, we can use status code, we can write out to the response, and then we're going to end it. So this is a lot like all the other functions that we were doing earlier with the HTTP core module. Finally, we tell it to listen on port 8080. So let's go ahead and make this call and see how this works. So we will call node index.js. So our server's running now, and I will make a request to the page. And there we go. So here are the request and response objects. Just looking at them, we can see that these are very similar to the ones that we use. In fact, they are the same objects. And now, let's look at the request in the browser. So here's our page that we told it to output. And if we look at the actual request, we can see it's a 500, which we told it to be, which is an internal server error. And then we added this powered by, which is Express and Node.js. So this executed exactly how we expected it to. So at this point, we've installed Express, and then we've used it. So, in summary, we discussed what Express was, which is a web application framework, and we talked about what a web application framework was. And essentially, it is a collection of utility and code that helps us build an actual application to run on an HTTP server. Then, we installed Express and then quickly used it. Now in the next video, we're going to expand on some of the things that we can do with Express, and we're going to start with routing. Welcome to Routing Basics, which is part of the course The Complete Guide to Node.js. In the previous video, we looked at installing and using with the basic setup of Express. Now in this video, we're going to learn what a router is and how to use one in Express. So first, let's talk about what a router is. So essentially, a router is something that takes requests and then routes them to the correct functions. We have touched on this topic before in the previous sections when we actually built a simple routing app. But now we're going to look at it specifically in Express. Now this is needed in Node.js and Express because the HTTP core module has only one entry point for every request. A web application does not want to serve the same response for different requests, so we need to be able to route a different request to a different response. And Express has this built in, so let's go ahead and use it. Just like the last video, we're going to use Express 4.14.0. Now if you don't have it installed, remember to go into the directory where this package.json is, and then run npm install, and that will install Express. I have it installed, so I'm going to go ahead and jump into the code. So let's open the file methods.js. Using this, just like before, we have to require Express so we can use it, and then create an instance of it, and we're going to call it app. So from here, I'm going to run through all the different ways that we can use the router, and then I will show the example with them in the console. So first off, we're going to use the HTTP method to define the route. So for here, we're going to say get, and then we're going to pass it a URL, and that's root. So this should match a GET request to the root. And then we're going to define a POST request to root. Now, there are many more functions and methods that you can actually use. But to be honest, the four most popular ones that you're going to use are the main HTTP method ones, which are GET, POST, PUT, DELETE, PATCH. So these are the big HTTP methods that you can use. Next, we're going to look at all, which actually just means any method to this URL, run this function. So gets, posts, puts, they will all run this function. Now, we'll move on to actually doing character matching. So before, the URL had to match that string. And now we're going to go beyond that. So first off, we can kind of talk about some simple character matching by using, for example, like a question mark to match one character or a star to match a bunch. So for example here, this will match ABC, but it also match ABCD, ABCDE, EFG, and so on, with as many characters as you want after it. And then this function will run for each one of those that match. In addition to this, we can use regular expressions. Now, we cannot cover completely what regular expressions are because it is a huge domain of knowledge. But just know that it is a very powerful way to match text and write very, very little code when you use a regular expression. So for example here, as you can see, this will match cats, and then this is an OR, and dogs. But in addition to this, this question mark says that the S on each of these words is optional. So it'll also match cat and dog. So it'll match cat or dog or cats or dogs. And then it'll execute this function. Moving on, we can see that we can actually add parameters. So here, you just put a colon and what you want the parameter to be named. In addition to this, you can define then some matching to say only fish or pony here will match that animal parameter. And then once you have the parameter, you can use it. It'll be part of the request. So request params and then the name. So we name this one animal, so we can use animal here. And so this will output that when we match this route. In addition to this, you can just use it without matching anything, and then this will match everything as we have the colon here. And again, we can use it by using user. So now let's talk about route. So route is very similar to just using the HTTP methods, with the difference that you just define the URL once. So here we're saying use Dexter, and then on a GET request, run this function, and on a POST request, run this function. So if we have the same URL that has multiple methods that we want to run off of, this would be a great way to do that without having to rewrite the whole boilerplate of an app GET, then that URL, then an app POST that URL. And that brings us to the final thing we're going to look at, and that's modular routing. So we've actually defined some routes in a different file, and then we're going to pull them in and use them with this application. So here we have router module.js. So let's open up that file and see what's in it. So we have to use the express router, so we require express, and then we create an instance of it. And then a lot like we use with the application, we can use the same things here. We can use get, we can use post, all those methods. So here we're going to say on the root, we're going to say this is a relative root. Now that means it's not going to run just on the absolute root of the application, but it's going to be relative to how it's used in the context of the application, which we will see that in just 1 second. And then we can even use other URLs. So we can do pattern matching, we can use parameters, all of that here. And then we export this router. So again, if we jump back to methods.js, we see that we define this as gizmo, and then we're going to bind it to the /gizmo directory. So the relative root would be relative to this. Now this is a great way if we have a group of routes that we kind of want to keep together and should operate underneath a directory. We can define them and then require them and use them as needed. And finally, we're saying listen on port 8080. So let's go ahead and run through these routes and see how they work. Now let's go to the console. Now I'm going to do this a little differently in that I have two consoles open to the same place. So in one, I'm going to go ahead and kick off our Express application. So it is running. Actually, let me redo that one time. So let's go to the console and run this. So I'm going to run this a little differently in that in one console, I'm going to run our application. So there's Express running. And then in the other, I'm going to use curl, which curl is a command line way of making requests to an HTTP server and getting the response back. So it'll be curl. Then we want to put in the URL, which is localhost port 8080. And then we're going to go to the root, and then we can do -x, and then we can define the method. So with this was the root method with a GET request. We run it, and then we see that it returned root here. Now, because we just returned a string, which was usually one word or just a couple, without a line break after it, it actually then just put the prompt. So as I execute these, we can see what's returned at the very beginning of the line. Okay, so that was GET. It executed how we expected. So we should be able to make a POST request. And we'll run that. And we see it returned POST. And that's what we defined. So it's the same URL, but we defined different functions to run, whether it was a GET or a POST. Now the next thing that we defined was the all URL. So we will put all, and then we will call it with the POST, and we see it returned all. Again, we can do this with a GET. We returned all. We can do it with a put. We can do it with a delete. We can do it with a patch. And we see all of these all executed the same function. So that all matches any method to that URL. Now the next thing we did was pattern matching. Now this was a GET, so I need to put GET back here. But we said ABC. So we see ABC matches. We can come back here, we can say DEF, and we see that matches, and it runs the same function. And we can put as much as we want in here, and that'll keep matching. So that's kind of the simple pattern matching. Now the next one we did was cats or dogs, or cat or dog. So we can see cat, and it returned cat or dog. We can put an S in there, because we use the regular expression. We see that works. We can do the same thing with dog and dogs. So again, these are different URLs that are matching the same function and executing that function. After that, we added a parameter. Remember, our first one was animal, and we defined that as fish or pony. This is a get, so we got to keep it a get. So we will pass in fish. And as you notice, it returned fish because we had that parameter in the request, and we said to use that when we output it. Now notice what happens when we put pony in here. We see that then fish changed to pony because it should pick up whatever's in the URL and define that as the parameter. Another parameter we used was if you typed in user / and then the username. I'm just going to put Josh here, and we see that it returns Josh. And then you can add in whatever you want here. It can be 1, 2, 3, 4, 5, and it returns Josh 1, 2, 3, 4, 5. So we can see that it's matching those URLs, binding that parameter, and then putting on the request, which then we can do whatever we want with it in that function. Okay, so then we used app.route. Remember, this is the one where you define the URL once, and you define multiple methods. So we defined a get and a post off of Dexter. So a get, return Dexter, which is what we wanted. Actually, I should take that back, because that was user Dexter. We want to get rid of user and just call Dexter. So there we go. It should be get a Dexter. And then we define the post. So we run post, and we see post a dog. And I put post a dog because Dexter is one of my dogs. And Gizmo's the other, which leads us right into using that relative routing module. So all of those methods were with get, but we can call Gizmo. And we can see this is a relative route. And that was the return object from just the root of that modular routing. Now we could actually take that router and define it on any number of folders, or more likely, anything that we want. Like we didn't have to have it Gizmo, we could have defined it to a different URL, and this would have returned this as a relative route. Finally, the other thing we have inside this module is bark, and we see bark. So we can see that there are many ways that we can route and then define a function so that we can get the exact function we want for the exact request that comes in. So in this video, we have seen how to use express routing. We started with a simple HTTP method and a URL and matched those up to functions. Then we pulled in character matching and then added parameters. And finally, we made a modular route that can be defined in another file and then pulled into the file where Express has been created. In the next video, we're going to see how to use middleware. Middleware is one of the most powerful pieces of Express. It is the core of any Express application. Welcome to Middleware Basics. In the previous video, we learned how to route requests. That is the critical first step in building a web application. In this video, we're going to look at middleware. We will do this by discussing what middleware is, how to use it, and then how to write it. Middleware is a core piece of any Express application. This is where all the useful things happen. In fact, routing is technically a piece of middleware, and this is the core piece of what a web application has to do. So, middleware is a function that will execute on requests, and then what it can do is literally anything. Now they view the request and response objects and can also add to these objects. Many times, middleware will work together. For example, when processing a form, we would have to install a middleware piece that will actually process the data off of the form and put it on the request. And then later, with another piece of middleware, we can then do something with that data. Now, Express is designed to just be a thin layer, which means that most functionality that is in request really is not in Express. It is in the middleware. Let's go ahead and see this in action. Let's open up middleware.js. So the first thing we do is require Express, and then we create an instance of it. Then, to use middleware, we use the method use. And inside of it, it will take a function where we can pass request, response, and next. Now in this piece of middleware, we will just be outputting the URL. So we'll be logging each request. Now this should look very familiar to what we're doing with routing, except that we have this next function. And what this does is this actually kicks off the next piece of middleware. If we have a piece of middleware that is not going to finish the response, then we need to call next so it continues on. Now that brings us to the next piece of middleware. So this we've already done. And like we said before, routing is actually just another little piece of middleware. So instead of using use, we'll use get, and then give it a path, and then we'll use request response here. Now we don't have a next because we actually end the response. So we don't need to have it continue. Now the next piece of middleware we're going to use is we're actually going to create a router. Now remember, we did this before, but we had the router in a separate file, and then we added relative paths there. So we're going to do something similar, except notice here that we can actually use here, and then add a piece of middleware. So we're actually going to log only inside the router. So we're going to say router log here, and then output the URL. And then we call next because, again, this is not the final function that we want to run on this request. So we kick it off to the next piece, which, if it matches this route, it'll be this. And then notice, to use that router, we actually use the middleware use. So we take that router and we apply it to a route. So again, as you can see, everything in Express is pretty much just set up as a middleware. Now Express comes with some useful middleware, like the static. Now this takes a folder, which we're defining as static, and as you can see in our directory structure, it's right here, and it has one file in it, test.html. So if any requests come in that match any of the files in that directory, it will send them back. Now previously in a video, we had taken a request where we returned a file by piping. And this is pretty much what happens with Express static. It'll take it and then pipe it to the output. And this final piece of middleware is here to show that order actually matters. So we've defined test.html again, which should match this piece of middleware. But we've defined it as well here. So when we call this, the first one will run, and this will actually end the response, and it will never come to this. So when we look at this, middleware will run from the first one added to the last. So the first thing that should happen is we log each request. And then depending which route it hits, any one of these could run. And finally, right now, this should never run because this would actually match all the requests that come through. So let's actually run this and see this in action. We go to the console and we type node middleware.js. So we run it, and then I'm going to take a browser and then I'm going to make a request to the different URLs. So the first one we're going to do is the root. Now if we look at the middleware, we can see that this makes sense that we just have this, because it logged the response and then this matched, and then it ended the middleware chain. So now let's put in dogs, and then that should actually fire this one, because again this runs on every one. This fires on every one that comes into the router, and then this will match the URL for dogs. So let's call that. We'll look at our console here, and there we go. There's the URL used, and then here's a router log logging the same thing. So as we see, these pieces of middleware are running in order and executing on the ones that match. Finally, let's call this static middleware. If we look, we see that the URL called. Okay, so let's call this static, and remember that it's test.html. So we call this, we see that it logged test.html. The browser has the correct page up, but this never called, because if it did, we would see another console log over here, and we do not. So let's go ahead and kill this. Then we will comment this out, save it, and then rerun this. Then if we make another call to static HTML, or I should say test HTML, we see that it logged it and we got this log. So this actually executed because this did not exist. Now we also could have put this underneath it and the same result would have happened in that this would call and this one would not. But this is a good example of how we can add middleware, how it runs in order as well. I'll go ahead and stop this. So the next thing we'll look at is kind of how we can write our own and how middleware kind of works together. So let's go ahead and open the file custom.js. Again, we require Express and we create an instance, but this time we have another package named cookie parser. And what this does is parse cookies that come in from the request. Now, we just use it here and we don't have the internals of what this is doing. But what it does do is take the cookie and all the cookies that are in the request, it puts it on the request object. So without calling cookie parser, we would not have the cookies object on the request object. And we can see that here. We're going to log it out to here. So without this, this would not exist, the cookies. So this is a perfect example of how middleware works together. So we will write our own, which we've defined here, and we're going to create a custom object, and then we're going to put can you see this equals yes off of it. So we are adding a property onto the request object so something later can use it. And we are going to use it right here in the console log. And again, we use the example of having a form, so we'd have something that would process all the fields that came over on the form, would put them on the request object, and then we can do something with them. Say, look something up in a database, check to see if someone needs to be logged in, and so on. So we have a simple piece that does something, that usually adds something to the object, to the request object, and then we do something with it later. So let's go ahead and run this and see our cookies and custom object off of request. This time we'll run node custom.js. And we'll make a request to root, and this kicks it off. And as you can see, this is cookies, so this is a blank object because we did not send any cookies, and this is custom, which we have defined. Now if we actually commented out the cookie parser, this actually disappears and it should be undefined. So we will stop this, restart it, and then re-execute. As you can see, it's undefined. So that cookie parser middleware is adding that object for us. So as you can see, this is how many pieces of middleware run, and this is also how we can design our own custom middleware to add functionality to Express. Now that sums up our video. And in this video, we've discussed what middleware was, which is just a function that runs in order as it's defined in Express. And because of that, it means that middleware is a core part of any Express application. Then we added some middleware to an application and then executed it. Finally, we saw how middleware can work together and how most of them work, and then we wrote our own custom middleware and executed that. Now in the next video, we will see how to handle errors in Express, because everyone makes mistakes. Welcome to Handling Errors, which is part of the course, The Complete Guide to Node.js. In the previous video, we looked at middleware, and that it was the core of any Express project. Almost all the functionality that people associate with Express actually comes from middleware. In this video, we're going to take a look at handling errors in Express. we will see how they bubble up in Express and what we can do to handle them correctly. Now, errors are an inevitability. They will happen. They could be caused by our own mistakes or errors in the code. They could be caused by things that are completely out of our control. If we have a site running in the cloud and there's a service disruption with our database, our site will throw an error. We need to be able to handle this situation correctly. In a previous volume and section of this course, we discussed handling errors in Node.js. The ideas there still apply, but we will want to make sure that we handle errors the Express way. Now open up the file errors.js in section 1.4. Just like all the other sections and videos, we are going to be running Express version 4.14. And we set it up the same way. We're going to require Express and then create an instance of it. So first, we have the normal route to root. This should work the exact same way as it has in all the other videos. But next, we have a route to error. As you can see, we will throw an error immediately when entering this route. Now, like many examples in this course, the situation is arbitrary, but the application of this should be clear. This could be the fact that the database is down and we are trying to make a query. It could be that we have a bug in the code and an error is thrown. This is showing what happens when an error pops up that we did not expect. So let's go ahead and run this and see what happens. So we do have a handler down here that's commented out, but first let's see how Express handles itself. So we will run node errors.js. I will grab a browser and then go ahead and go to the different pages. So we will put error in here. As you can see, we get a stack trace in the console, and now let's look at the browser. In the browser, we see that there's also a stack trace there. Now there are ways that we can actually turn this off so it doesn't go to users, but we do not want to rely on the default handling of errors in Express. So let's see what we can do. Another thing to notice is that that error throw did not immediately stop Node. We did not break out of it and exit. So Express does have some handling built in, but again, we do not want to rely on it. So let's go ahead and add our own. Now, just like everything else in Express, this is going to be a middleware. As we can see, we use app use. I will comment this out, or I should say comment it in. The only difference is that, as you can see, there's actually one more parameter in here. So it takes 4, and it is the error as the first one. So by defining a function that takes 4 parameters with the error as the first one, this defines it as an error handler. So the default Express one will not fire, and this will fire. So here we're going to log the error to the console, just like before. We're going to set the status code to 500, which is the correct status code, as that is a server error, and this is a server error. And then instead of sending the stack trace to the client, we're just going to say there was an error. Now, one thing to notice is that between this piece of middleware and this one, we have one more, and that is a simple log. And what I want to demonstrate with this is that when an error is thrown, it will actually skip all the rest of the middleware and then go to the error middleware. So we will stop this and then rerun Node. So I will call the error page again, and there we go. So this is the console log of the error, and you can see we would expect, as you can see, we would expect it to log here if it ran that piece of middleware, but it didn't. It immediately went to the error handler. So that's another thing to keep in mind, that an error will completely jump over any other middleware in the stack and immediately go to the error handler. Now by default, you're going to want to put your error handlers near the end, because you want all your other middleware to run, hopefully, before that error is thrown. And then at the end, you want to say if there's an error, we will handle it this way. So now there's one more thing that we're going to do, is we're going to comment out this throw error, and now we'll run it next. So this is another way that you could throw an error in Express. Now, when would we do this with the next? This would be an example of us calling like an asynchronous call. So you make a database call and you register a callback where you say error is the first parameter and the data is the second. And if you get an error back, now you're not just going to want to throw it, you're actually then going to take it and put it into the next. So you'll execute next, but you'll execute it with an error. And that as well will kick off the whole error handling chain. So let's stop this and then execute it there and then call error. As we can see, it gets handled the same way. So that wraps up handling errors. Now in this video, we've seen how to build an error handler in Express. Now much like everything else, it is just a piece of middleware, but it takes 4 parameters with one of them, the first one, being the error. In addition to this, you want to add it at the end of the middleware stack because that makes sense. If an error is thrown anywhere in the stack, we want to have this at the end to handle it. Now, in the next video, we will see how to debug in Express. This is a perfect continuation from handling errors, as we can now see how to track down the errors once they occur in Express. Welcome to Debugging in Express, which is part of the course, The Complete Guide to Node.js. In the previous video, we looked at handling errors in Express. In this video, we're going to take a look at debugging in Express. We will do this by looking at the 2 easiest and best ways to debug. Now, continuing from the last video, along the lines of what to do when something goes wrong, we are going to cover debugging. It is a rare event when we just write out code that works exactly how we expect it to. Which brings us to debugging. Debugging well is often underrated. We, as developers, can waste untold amounts of time trying to track down why code does not work a certain way. Good tooling should cut down on this time. Now right up front, I will talk about something we have been using extensively so far, which is console.log. This is not a debugging solution. It does have its place and its uses, but for real debugging, it just does not cut it. This video will cover some tools that will help us track down bugs and issues quickly. Now for the code for this section, we will use the same code from video Routing Basics. Now that video was everything that dealt with routing. So while this code is not broken, we will demonstrate the tools that will make tracking down problems easy using this code. First thing we will look at is getting Express to output logs so that we know what it is doing at any point in time. Now we do not need to add any new packages or code, as technically this really isn't a tool. All we really have to do is set an environment variable. Now we will do this in the console. I'm using Mac OS X, so this will be slightly different for Windows, but the variable is the same and what we set it to is the same. So to do this, we're going to set debug, this is a variable, and we're going to set it to express star, and then we run node. So we're going to execute this. So this tells Express to log everything out. And as we can see, there were a bunch of messages that just got logged out. Now if we scroll up, we can kind of see the very beginning here with the application actually loading up the script that we gave it, and we see it moved on to the router. We were doing a ton of router stuff, adding methods and routers. Then we saw it moved on to the router because here we're doing a ton of routing, so there are a ton of messages related to that. Now I'm going to go ahead and open up a browser and make a request. So as you can see right here, this was a request coming in, dispatching get to root, which is where I went. So this is a good way to see what Express is doing internally, so it's not just a complete black box. Now another thing we can do, I'm going to come in here and stop this, is that these are a lot of messages, and let's say that we are not concerned with everything else that's going on. We are just concerned with the router. So we can actually then say, I just want to log router messages. So as you can see, this is much fewer messages. So it's easier to find what we're looking for. I'll make another request, and we see it logs that as well. So, like I said in the beginning, this isn't a true tool, but it's great to kind of see what's happening inside of Express, especially since we just say require Express, initialize yourself, and now I'm using you. Now, let's do some real debugging. So the first thing we will do is look at package.json, and we'll look at the scripts object, and we see that I've added a new script called debug here. So looking at this, it's going to say execute node, and then we have some parameters here. Debug, because we want to debug, and now this is an important one, inspect. Now this will set it up so that we can actually attach Chrome and its developer tools to Node and inspect things, which we will do here in just 1 second. So this is an important parameter. And then debug-break. And what this does is stop the code right at the very beginning, so that if we want to add a breakpoint, we can before it actually gets to that code. So let's go ahead and run this and see this in action. So we're going to go back to the console. I need to stop. And we're going to run npm run debug. Remember all the way back in the beginning that if we have a script in scripts, we can always run it with npm run and then the name of the script. So here we're going to execute it. All right, so start it up. So the first thing we notice is that it says this is an experimental feature and could change at any time. Now pretty much it's just telling us that this could work differently in the future, but honestly it works really great right now, so we can use this to debug. The next thing we notice is that it actually gives us a URL. So we're going to copy this URL and we're going to put it in Chrome. So here I put it into Chrome and launched it. As you can see, this is the code that we have in our file. Now this gives us all the tools that Chrome has for debugging. Now we may have used these before if we ever debugged JavaScript in the browser. Well, now we can debug JavaScript in Node in a browser still with the Chrome DevTools. So here we can do many things. As you can see, it stopped at the first line. That's our debug break. I'll take a second here to kind of point out some things. Over here, we can see all the files that we've pulled in so far. We have the call stack here. We can set a watch if we want to watch a specific variable. Here are all the variables here, local and then global variables. And then up here we can continue, we can step over. So if we do this, we see that app was just set and now app has a value. Now we can completely inspect what's inside of this application. We can also set a breakpoint. Now this won't stop the code here because we're actually just registering all of these. But if we make a request, it'll actually stop here. So I will let this continue on. So that actually loaded everything up that we've defined. And then let's make a request. So I'll come over here and then call localhost 8080. And we'll see that it has stopped right here. So we set a breakpoint and now it's broke right here. So we can actually inspect the request and everything that's with it and the response and everything inside of that. Now in addition to this, we can come over here to the console and we can do the same thing. Now I'm just putting these in here, but for example, we can actually update the code on the fly. So right now it's set to 200, but we can go ahead and set it to 500 right here in the code, right here in the console. So we can actually test out code before writing it to run in Node. So this is our REPL, for example, but it's running in the context of the thread. So if we come back here and we let this continue, we'll see that it finished. So that's it for this video. Hopefully, it is very clear why this tool is very powerful when trying to track down bugs in your code. So in this video, we've seen how to get Express to log everything it does so it's not quite a black box. Then we saw how to run a full debugging environment in Node.js so that we can track down any bugs or issues there. Now in the next video, we will use templating in Express. So far, we've only been returning basic sites or even just plain text from our responses. Actually, let me restart that. In the next video, we will use templating in Express. So far, we have only been returning basic HTML pages or even just plain text from our responses. With templating, we can start to build real full web applications. Welcome to Templating in Express. This is the final video of this section. Last time we discussed how to debug in Express. In this video, we're going to take a look at templating. First, we will discuss what it is, and then we will use it. So far, our applications have had very basic responses to requests. Templating allows us to generate HTML responses based on the request. This is much better than having to create a static HTML page for every possible request. In fact, that is nearly impossible to even do. Templating allows us to define a structure of an HTML response and then insert certain variables into it to change how it renders. Now, this is a gross oversimplification, but that is the core basic idea of what templating does. Now, we will be using Pug, which was previously known as Jade. Now, this has many features, but we will focus on basic rendering and using layouts. I definitely recommend reading up and practicing with Pug, as it can do a whole lot more than what we're going to display here. Now, we will have the same basic setup as all the previous sections. So let's look at the package.json here, and we see that we have Express 4.14, and then we're using Pug 2.0. Now, it does say it's a beta, but it is really close to a release, so this should be safe to use. Now let's look at some code. So we will look at index.js. And it starts off the same way. We have to require Express, and then we have to initialize it. The next thing we do, though, is new. We're going to use a new method called set. So what this does is it sets a value on the application setting object. Now, up until now, we have not needed this. But here, by doing this, we're going to say that the views that we want to render will be in the directory views. And then the view engine that we're going to use to render those views is Pug. So by setting that, we are configuring Express to allow us to render. And we can render right inside of the request. And we can render right inside of the function. So if we go to get root, we can see that we're using response render. And we're telling it to render index. Now if we look up here, we know that this file should be in the views because that's where we told it to be. So if we expand this, we can see that there's an index.pug. So let's open this up. So looking at it, it looks like an HTML page without brackets. And that is kind of what it is. So all we have to do is create an opening tag, and in the rendering engine, Pug, will know how to create the closing tag. So here, we are saying HTML, then page, and a title, and we're going to set it to Pug-based templating. And then there should be a body with an H1 with Pug-based templating. So let's go ahead and run this and see the HTML that it produces. So we come over here and say node index.js, that's running. So I'll grab a browser here and we'll take a look at that. So here's the page in the browser. As we can see, we have an H1 Pug-based templating. We can go ahead and look at the source, and we see that we have an HTML head, title, and we have a body and an H1. So it rendered exactly what we expected it to. But what good is this? We could have literally used a static HTML page for this. Well, that's where our next example comes in. So let's take a look at that. If we go back to index.js, we can see we're going to say app-get layout. Now in here, we're going to use layout as a view, and then notice that there's an object here with some properties. So we are actually passing this into the rendering. So let's take a look at that. So we find use layout, and we notice that it says extends layout.pug. So let's take a look at layout.pug. Now here, this looks a lot like the last one that we did. We have a head, we have a title, although this time it's going to be set to the title that was passed into it. Then it's going to have an H1. Then we're going to put an image in the page, which is going to be the Express logo. Now for this to work, we have to have the static middleware running, which we'll look at here in just a second when we go back to index. And then we have this here that says block content. Now let's go back to use layout, and we see that this says block content. So what that is saying is take that layout and then match that block content and replace it with this. And then with this, we're going to say, here's a message from the server, and we're going to output the message. So let's go back to the index to take a look at this again. So when we go to layout, it'll use the view useLayout, passing in a title and a message. So what this should do is render it by taking that layout.pug, which has the image, and it has a spot that we can replace with the message. Now in that layout, there's an image. And then that's where we have to use express static. So we have a static folder, and then we have the image inside of it. So let's take a look at that. I will bring the browser over and we'll look at that. So it was /layout. Now we execute this. And as you can see, this is not going to win any design awards, but hopefully it kind of demonstrates what we're doing. So this is a layout. We had templating Express, and then we had the Express image on the page. And then this was actually our view that we wanted to do. Here's a message from the server, and then this was set from that message. Also, if we take a look at the title, we see that that was set as well. So hopefully we're starting to see the power in this, that we can have HTML that is generated based on the request. Now let's take this one step even further. We will create a route based on a parameter from the URL. Then we will create the response based on that. So our example here is going to be a simple user profile. So we have this routes.users, routes/users.js. So let's go there, take a look at that. And we use a router. We want to bind routes to a directory. We want to bind routes to a route already. So here we're going to say username, which again with the colon means that we're going to bind a parameter. And then we're going to pass that into the view users/profile, passing in the username and the title. So let's take a look at that view. So again, that's going to be under views, users, profile. Again, this is extending the layout. So we define the layout once and we can get a similar look across multiple pages, and we don't have to keep repeating that same exact HTML structure. And then in the content, we're going to put an H2 and say this is username's profile, which this will be replaced with the username that was passed in. Again, I would recommend that you look up Pug and the many things that it can do, as we do not have the time to cover everything Pug does, but hopefully I'm covering the very basics that will definitely get you started, and using their documentation, you should be able to make very complex views in no time at all. So let's go back to index, and we'll see we require that, get users, and then we're going to bind it to users here. So let's take a look at that in the browser. So we had that at users, and then we can put a username here. And as you can see, our template, our layout is exactly the same. And this time, we have different content in here. This is Josh's profile. And it changed our title. And because this binds to whatever we put in here, we can change this to, for example, Gizmo. And we see that it loads Gizmo profile, and this is Gizmo's profile. So remember a few videos ago when we discussed the fact that middleware can work together to create larger applications? This right here is essentially what we are doing. We have multiple pieces of middleware that are working together to create a web application. So that sums up this video, and in it we've learned all about templating. And templating is a key piece in any web application. It allows a site to have a similar look with layouts and not have to redefine it for every page we create, and most importantly, be able to create dynamic responses from requests. This also ends our section. And in this section, we've learned all about Express. We first learned that Express is a web application framework. All web applications need a framework like Express, as HTTP does not specify any of the things that current web applications do. Then, we started going through the major features of Express, like routing requests to responses, using middleware to add functionality to Express, handling errors, doing some debugging, and finally, templating. we ended up building a proto-web application. All the pieces are here for us to start building real web applications. In the next section, we will discuss a specific package for Express named Passport. It is one of the leading packages for authentication in Express. We will create very basic authentication to a site and get even closer to a real web application. Welcome to the final section named Passport and Express in the course, The Complete Guide to Node.js. In this section, we will build a small web application using everything we learned so far and also some new things. We will be creating a page that needs an authorized user. Then we will build the login page, install Passport, and then actually authenticate the user. Now in this video, creating a protected page, we will be laying the foundation for the later videos in which we add more things in. And we will do this by creating the basic framework of the application and in creating a middleware to require authentication. So this section can be seen as a culmination of everything we have done so far. We will be using all the things we learned last section to build a web application in this section. Now, in this video, we will be creating a site that has one page that is protected so that you have to be authenticated to access it. Now, we will not create the full authentication chain in this video, but we will by the end of this section. Now, in this section, we have a new concept, which is a session. Sessions are tracked by creating a cookie that will uniquely identify each specific browser that is making requests. We can then know if the same browser makes a request at a later time. This is important for web applications. In HTTP, each request is meant to be stateless. This means that there is no built-in mechanism so that a person is known as the same person from a separate request. Now, with a session, we can then store some information about the person and then tie it to a request. Now, a perfect example of this is storing what user a person is. And by doing that, we don't have to ask them on every request who they are. Now, if you've ever logged into a website, the backend server has had a session that stored information about you. So let's get started. First, open up package.json so we can see what is installed. Here, we have Express and Pug, which are both things that we've used before. We have one new package, and that is Express Session. This is actually what will create the session for us. Now let's actually look at some code. We'll go to index.js. So we have some requires at the top. We're going to need Express and Express Session. And we'll store that in Express Session. And we'll use those here in a second. Now the next thing is we're defining some middleware that will require authentication to protect a page. So right now, this will always fail because we are statically setting this to false. And this is actually what passed through. So if this ever becomes true, we'll go on to the next step. If not, we will redirect back to root. Now, this is completely arbitrary in that it's always going to fail, and eventually we'll want to go to a login page. Now, when we pull in Passport, we can change this out, and when we create a login page, we can change this out. But for now, we are just saying you can't. For now, we are just saying there is no way that you can get to this protected page. Next, we create an instance of Express, and then we set up our view engine, which is Pug. And then we set up our session. Just like everything else, it's going to be a middleware. Now, there are many options we can use, but we just have the basics here. So the first is a secret. This is used so that the cookie ID can be signed. And then resave and save uninitialized are used to determine when and how it's going to save to the backend store, which, because we haven't defined anything, is going to default to memory. So each session will be stored in memory on this computer. So by putting this middleware in, we will have access to the session. We will have access to the session object on the request. Now, I do recommend that you go to the Express session GitHub page and look over the documents there to see all the possible options. Again, these videos are designed to introduce you to these concepts, get you used to them, and then you can take some time and then actually dive into them deeper when you're building your own applications. Then we have a simple log, middleware. Then we have a root, which in here, you see we are using the session object. So we are saying keep a count of how many times you've been to this page. So here we're saying if it's not set, set it to 0. If not, then just return that number and then add 1. And then we're going to log out the entire session. And then we're going to render the index view, which we'll look at the views here in just 1 second. But this code right here, each time we come back to this page, it'll increment. And the reason it can go up is because when it's keeping a session, it knows that I am the same user. So each user will have their own count, but that user can increment it. And finally, the last route that we have is a profile. Now this looks a little different in that we have an array of functions. Now when you pass an array of functions to a route, it'll register all of them, and then it'll execute them in order. So by having the require authentication first, if we come up here, so this will fire first, this will be false, and instead of calling next, it'll call a redirect. So technically, this function here that we've defined to render profile will never ever fire with how we have our code now. Now again, by the end of this section, we will have it so that it will make a determination whether if you're logged in or not and send you to it. But for right now, this will keep us from getting to it. So we have a protected page in profile. We just have no way to authenticate to see the page. Now let's go ahead and look at the views. So we have a layout. It's pretty simple. We have an H1 that's going to say complete guide to Node.js. And then we have a couple links, one to home and then one to the profile. And then since this is a layout, we have block content. We look at the index. It just says there's not much here, so log in. So this is our site. As you see, it's a nice little foundation. We're starting to roll in more middleware, and middleware that actually does some stuff that we can work with. For example, the session, which then we can use here. So let's actually kick this off and then make a request and then see how this works. So first thing we need to do is start the server, and then we'll load it in a browser. So here's the page. This is exactly what we think the template would be. And we can go home, that works. And we try to go to and then we try to go to my profile, and we see that it actually takes us back to the home, which is what we're expecting. That's what we had in the require authentication middle. Okay, so let's go ahead and look at the console and see what was happening there. So, as you can see, we have the session here, and it is slowly incrementing. So it started with 1, then it went to 2, then it went to 3, and then 4. And also we can see, because we're logging the URLs of where we went. So first we went to root, which makes sense. Then we clicked the home link, which was root, so that incremented it to 2. Then we tried to go to profile, which we could not do, and then it took us back to root, which is what we expected, and put it to 3, and then we tried it again, and that put us at 4. So we can actually see everything working together. The session is working, it's tracking how many times we're going to the root. We can see the require authentication is working in that we cannot get to the profile URL. And so we are ready now to actually start building on top of this. Put a login page and then actually authenticate. Although I do want to demonstrate one more thing. So let's go back to the browser. Here's the browser. Here's the browser. We will go to inspect, and under here there's application. And then here's the cookie that was set for the session. So if we delete that, and then we refresh the page, and we go back and look at the console, which we will do right now, we will see that the count was reset. And that is because the cookie is what uniquely identifies this browser to the session. Once we deleted that cookie, it could not connect us to a session, so it recreated a new session and started counting from there. Okay, so that brings us to the end of this video. In this video, we've learned all about sessions and how we can store information on the server side between requests. And then we created a basic site which has a page that is then protected behind authentication, but we have no authentication to get there. Now in the next video, we will take the next step and create a login page. Now in addition to this would include creating a form and then creating the code on the back end that would process that form to get the information out of it. And this is something that we have not done as of yet. Welcome to creating a login page. In the previous video, we created a small site that had a protected page. In this video, we're going to take a look at processing forms. So first we'll need to create a form to be processed, and then we'll need to get the data out of it. So far, we have not had any way to get data to the server. We have been in a read-only mode for our websites. In this video, we're going to actually accept data from the user. We will do this with the form using the HTTP method post. Now, forms are defined in HTML for this very reason, to send data. Breaking this down to its simplest parts, it is literally just keys and values that the browser sends to the server. We then will need to parse that, which then we can use the data. Which brings us to the first package that we will need to install to do this. So let's open up the package.json for section 2.2. So we should see a new package in here, body parser. And we're going to use this, and this is a middleware that will take a form and then it will turn into an object that we can easily use in our application. So let's go ahead and see how to do that. So open up index.js. As you can see, we have all our requires, and now we've added body parser. This is pretty much the same code from the previous video, with just a couple more things thrown in to do some more items. So after we require it, we're going to use it and put it in the middleware chain. So we're going to say body parser URL encoded. Now, we can also use JSON, but we are not getting any data by JSON, so we don't really need to parse it. We're only going to have URL encoded data. Now, when we actually create the form and submit it, we'll actually see what that is. In addition to this, we've updated require authentication, and we're now saying we're going to redirect to login instead of root. Now, to redirect to login, we actually have to have that route, which we added as well. So let's go down and take a look at that route. So we added a get to login, and then this is just going to go and render a login view, which we'll look at in just a second. And then we added a post. As we said before, we're going to add a form that uses the method post. So this will take that data, and then we are just going to look at it. We are not going to do anything with it just quite yet. But the fact is that we will have the data on the back end. And this body object is created by our middleware body parser. Now let's actually look at the form. It's in views under login.pug. So we're extending the layout, and then we have a block content. And so here's our form. The action is saying go to the URL login and use the method post, which, again, if we look at this, we can see that we are saying app post to login. So we're telling our form to go to this route right here. Then we have two inputs. One's a text, that's going to be the username. The other is a password, and it's going to be password. And then we have a button to actually submit the form. So first, let's go ahead and look at this. So we'll load it up, just like before, node index.js. And the first thing I'm going to do is I'm going to run through it, and we're going to watch the console, and then I'll flip it over and we'll run through it and we'll look at it in the browser. So I'm going to open a browser here and load the page up. Okay, so we see that I went to the root homepage. Now I'm going to click My Profile, which then should try to go there, see that we're not logged in, and kick us over to login. Working exactly how I expect it. And I have a form, which I'm going to type in a username and password, which I'm just going to use Josh and password, and I'm going to log in. So there we can see we posted to login, and here's the data. So we were actually able to pull that right out of the form. And now that it's on the back end, we can now use it to authenticate, or if this wasn't specifically a login form, if it was any sort of form, we could then use that data to do whatever we wanted to with it. Okay, so I will do this again, and this time I'll bring the browser over, and then we'll look at it from the browser's point of view. Here's our site, and then we're going to go to My Profile, which should try to log in, and it does. So here's our login form. Again, we're not going to win any awards. We're just throwing some HTML on the page. And then I will go ahead and view the page source. And as you can see in the HTML, we have this form, and it has the action and the method of login and post. And then we have the input for username and an input for password. So let's go ahead and fill this out, the same information. And then I'm going to go ahead and hit inspect, because we're going to look at the form when it posts. So I'll log in. Now all we did was in the request in the post, so that's why it's just a blank page. But let's actually look at this. So we can see that it was a post and it went to login. So if we come all the way down here, we can see that there's form data. We can see it's a key value. Username's Josh, the password's password. Now remember before when we said that we're going to use the body parser for URL encoded. That's because this is what is actually sent to the server. So this is a URL encoded form. So when we added body parser, it parses this into the key values. And we should also see this in the request headers. Here we said it's application www form URL x www form URL encoded. And with HTML and the form and it being URL encoded, and using the HTTP method post, we're able to take this data from a browser and send it to the server. And then using our middleware, we're able to parse it and then get that data out. So we are now to the point we are ready to authenticate, which we will do in the next video. So that ends this one. In this video, we have discussed forms and how they are a great way to get data to the server. Then we added a form and then we processed it and had the data on the server side. Now in the next video, we will finally add Passport and then authenticate some users. Welcome to Passport and Authentication. In the previous video, we learned about forms and processing forms to get the data out of it. In this video, we're going to take a look at actually authenticating a user. We will do this using Passport. So let's go ahead and jump right in. Passport is one of the most popular authentication modules for Node.js. We are using it in Express, but it is not explicitly just for Express. But I will say it works really well in Express. One of the great things about Passport is that it is modular. So they have these different strategies, as they call them, for authentication. This means that we can easily add or change how a user is authenticated. For here, we will use the local strategy for this project. Now it's called local because this is where we would have, for example, a local database of users. Now we will not cover how to do this, have a local database of users, because that is much larger in scope than these videos have. So we will not cover how to do this here because that is a much larger scope than these videos have. But we can easily change out this authentication strategy for things like Facebook, Twitter, GitHub, or many, many more. Passport lists over 300 different strategies as of the recording of this video. So let's go ahead and write some code and authenticate some users. So let's open up package.json, and we should see two new packages, which are Passport and Passport Local. Now Passport has all the functions that are the glue between a strategy and how Express expects things to work. And then the strategy is what is actually going to authenticate the user. So now let's use it. We're going to open up index.js, and just like the last video, this is the same code as that with a couple things updated. So we have our requires with the addition of having passport and passport local. So then we take passport and we're going to tell it to use this local strategy, which we've defined here, and we're going to create a new instance of it. So this is going to take a function that passes in the username, password, and a done function. This is where we put our logic for looking up and checking a password in a database. So as you can see here, this is very arbitrary in that we're just checking the password to see if it checks the password. And if it doesn't, we kick out and say you're not logged in, or we let you in. Now I want to stress that what we are doing here is not secure and should never be used. In fact, I would go so far as to recommend not building a database where we store the password at all until you've read up on the security of storing passwords. There are a lot of pitfalls with this with dire consequences. Again, the scope of building secure password storage is beyond the scope of this video series. To be honest, there are services out there that will take all the responsibility of storing passwords for you. And then if you're using Passport, you can then pull in that strategy and still get the advantage of not requiring another service to store the user information for you. For example, say Facebook. So again, I want to stress, do not do this. And if you do want to store a password yourself, please spend some time and look up the information on correct password storage. So again, we wanted to do this so that we had an invalid return and a valid return. So if you are logged in, if you are a valid user, we're going to just pass the username back. Now here's where, if we had a user database, we could pass much more information. Say like a first name, last name, everything. Groups they're a part of, stuff like that. Next, we define serialize and deserialize user. Now this is what Passport is going to use to put the user in the session and get the user out of the session. Here, because we have such a simple user object, just a username, we are really not doing any sort of serializing or deserializing. Now sometimes, some apps may just store, for example, the user ID. And when you get the user ID back, that does not give you enough information about the user. So then you can do something like look it back up in the database. And that's what you would do in the deserialize. So the serialize, you just pass the user ID in, and the deserialize, you bring it back out with the information by looking it up. So now we come to require authentication, and now we can actually finish it. So Passport will add the function is authenticated off the request object. So then we can execute that and we'll get a Boolean back to tell us whether they are authenticated or not. So how does that is authenticated function gets on the request object? Well, with some middleware. And then we have to run these. So we have Passport initialize and Passport session. Now one thing to keep in mind is that the express session has to come before the Passport section. And that's because the Passport session uses the express session, expects certain objects to be there that creates. So now we can actually look at the login post route. So here's our login, and we've gotten rid of the defined function we have because Passport actually has a function that will do the whole authentication process for us. So we are telling it what strategy to use, which is local, and then we tell it what to do if it was successful or not. So it'll redirect to root or it'll redirect to login. Now one thing is this is expecting the post to have the values username and password. If those are not there, then you can actually tell it to look for the name of the values that you change them to. But if they are there, it will just grab those and then call the authentication method to log the user in. Now there's another thing you can add here with flash messages. So for example, you could say, hey, that was an incorrect username password, and you can display that on the form. We're not doing that here, but that is definitely recommended. You want the user to know what happened. You don't want them to just log in, have it fail, and then just bring you back to the login form, because they may not know what happened. So finally, we've added the profile page. So we're going to log out the session here so we can take a look to see what it looks like. and then we're going to render an actual profile. We're going to pass in the username by going into the request, session, passport, user, and then getting the username. And again, we should see this when we output the request session. Let's take a look at that view. It's going to be pretty simple. We're just going to say welcome username, and we're going to extend the layout. So, all this time, let's actually run this. So first we're going to load it up in the browser, and then we'll take a look at the console. So we're going to run node index.js. And I will load up a browser here, and then we'll take a look at that. So we go to the root. So this is the site we're expecting. We built this a couple videos ago. Nothing's changed yet. The difference is we should be able to click My Profile. Should ask us to log in. And then first we're going to put in a bum password. Remember, it expected password, so I'm just going to put 1234. And there, it's telling us that it's unauthorized. We cannot go there. So we're going to try to log in again. This time, we're going to say Josh password. Now remember, on the successful redirect, we told it to go to root. So now we should be able to go to My Profile. As you can see, it let us in, and it's saying welcome Josh. Let's look at the console now. So here we go. So we can see the string of URLs that we tried to go to. Eventually we got the profile, which output the session. And we can see Passport added an object to the session. And that's what I was saying before, where the Passport session expects this session object to be created already because it adds just another property to it. And then here's where it stored the user, and we returned username with the username that we logged in as. So that kind of wraps up the authentication that we wanted to do here. So in this video, we've finally pulled in Passport and authenticated a user. We are currently using 4 to 5 pieces of middleware, depending on how you view it, to create an application that actually accomplishes a lot for only being 75 lines of code. All of the core foundational building blocks are here to create larger, more complex applications. So in the next video, we will discuss where to go from this point. Now we have covered a lot of topics and built many different things throughout this course, but the next video is the last video of the course. So that video is going to cover where do we actually go if we want to actually create more complex applications.